Sorry.
All right, good morning, everybody. Welcome to Dorsey Whitney. I'm Robert Hensley, a partner in our food and agribusiness industry group. And on behalf of the 500 lawyers at Dorsey Whitney and our 20 offices, welcome to Denver. We have our seminar today, which is entitled An Exploration of the Commercial Use of Drones in Agribusiness, Infrastructure, and Mining. We have about 100 participants signed up for this. So there's about 75 or so that are on the webinar. So if you see us speaking into the camera occasionally or something like that, that's what we're doing. This seminar is co-sponsored by 3 of our industry groups here at the firm that overlap in this space: our food and agribusiness industry group, our energy industry group, and our mining industry group. It's an information-packed seminar that covers legal, practical, and business aspects of the use of drones. And you'll notice I use the word drones. Others may use unmanned vehicles or something of that sort. I'm the moderator, and they're the substantive speakers, so they're going to be a little more technically correct than I would be. First, a little bit about the schedule. We'll start the program itself at about 8:45, maybe a little bit early Mountain Time. And again, we're trying to sync with the webinar so the people that are viewing will be synced up. There are 3 sessions. They're between 45 and 60 minutes long. You'll be getting breaks. The first session is Drones 101. The second is Privacy and Intellectual Property in Precision Agriculture, Infrastructure, and Mining. And the final session is a business panel discussion. We'll wrap up around noon Mountain Time. So some housekeeping. For those of you that need CLE credit, there is a sign-up sheet. I think it's the green paper, so you need to sign in so that you can get your CLE credit. If you're online, in the email you received about the program, there are 3 sign-in sheets, and for reasons I don't entirely understand, you have to complete all 3 sign-in sheets. And then you email those back to Michelle Hubble. Her email address is on the forms that you were sent. New York CLE rules, and apparently we have people from New York attending, people from all over the country attending via webinar. New York CLE rules require that we periodically during the program, we pop up and read a special number or announce a special number because New York thinks people cheat on their CLE compliance. Restrooms here are around the corner and to the right, so that's feel free to use those. For those of you that are attending the webinar, not here, there's a text box that shows up in the PowerPoint presentation or in the presentation. Don't use the text box for questions. Instead, the best way to do that is to text those to me directly, the moderator, or my cell phone. That's in my cell phone number to text me is in the box on the computer, but also I'll tell you it's 303-870-9707, 303-870-9707. Text those questions to me, and I will ask them of the moderators. So I'm going to do the introduction of the panelists for our first session. David White is going to be our first speaker. He is the Chief Operating Officer, Director of Sales at Juniper Unmanned. In this role, Dave leads corporate business development efforts while also focusing on developing long-term client relationships. His extensive organizational skills, business acumen, and technical background provide a solid foundation in helping clients implement, operate, and manage commercial UAS programs. He holds a Bachelor of Science in Mining Engineering from Colorado School of Mines, where he serves as a research faculty for the UAS Solutions team. And I'm going to go ahead and introduce Thad also at the same time. Thad Lightfoot is my partner here at Dorsey & Whitney. He is a partner in the firm's Regulatory Affairs Group and is a former trial attorney with the Environment Division of the U.S. Department of Justice. In nearly 3 decades of practicing environmental law, he's represented corporate clients in a variety of sectors, including agriculture, aerospace, mining, forest products, paper, steel, manufacturing, electronics, real estate, and the ethanol industries. In addition, he's represented the operator of major international airports for many years, and has recently advised clients on obtaining FAA exemptions for commercial use of unmanned aircraft. So I'm going to turn it over to David White.
Thanks so much, Robert.
Good morning, everyone. First, I'd like to just say thank you to Dorsey Whitney for inviting me to participate in this. It's a privilege to do so. And just for those of you on the webinar, to let you know that I have an updated PowerPoint, which we will be sending you after the event along with the thank you for the attending. So if there is a slide that does not correspond to what you have, you will get the updated flight in the future. This morning, my goal is to provide a high to mid-level overview of some of the more technical aspects of drone and the UAS industry. Thad will be dealing with the compliance issues, so I'm going to steer clear of those. But in preparing for our talk, I thought it'd be helpful to give us a general overview because I'm not sure at what level people are entering into the conversation today. So what we are going to cover today, or what I'm going to cover, is what is an unmanned aircraft system, the types of aircraft, a set of sensors and the data that those sensors provide, what UAS are currently being used for and possibly could be used for in agriculture, mining, and infrastructure. And then I want to give you some conclusions and then a caution to think about. So when I say an unmanned aircraft system, people typically ask me a few questions. And the first question I often get is, what should I call this? Is it a drone? Is it a UAV? Is it a UAS? Is it important? And is there a difference? Well, I would say yes. The word drone carries with it a significant connotation that typically has some baggage associated with military operations with it. And so even though it's a convenient word to use and easy to say, as a professional in the industry, I much prefer to use the word UAS or unmanned aircraft system because it better represents a system that works as a whole to enable successful flight and ultimately data collection. A second question that we typically get is, what can a UAS do? Well, the truth is, it can do an awful lot. And so that makes the answer both complex and simple because it really depends on what you need a UAS to do and what kind of data products you need to make your life better and to make you be able to make better decisions. And then finally, people typically ask, well, what's the best UAS or what's the best drone? And again, the challenge is it really depends because as you're going to see as we work through some of the options, there's a wide variety of types of UAS, and each has a specific characteristic that make it better suited for some applications than for others. So when I say UAS or unmanned aircraft system, what am I thinking of? Well, I'm thinking of a variety of interconnected elements that when functioning together enable the safe, effective operation of a remotely piloted aircraft that then creates a unique and specified data set. Each element performs a specific and unique function, as we said, and the key for UAS is it's a system. That's the reason I like the word UAS. On this slide, you'll see an image that represents one type of a system. This is from the Vinci Sirius Pro, in which there are two operators. One is operating a laptop. It has a ground control station. They do flight planning on that. That flight plan is then uploaded to the aircraft through an RF radio link. And you also have a pilot who has an independent and redundant RF link to the aircraft through a remote control unit through which he can then take possession of the aircraft or flight control of the aircraft and land that aircraft at any time. The UAS system varies depending on the type of aircraft and what the designer's requirements were when they were developing the aircraft. So some have said that there are up to 6 elements that can be used to define UAS. Because of the limited time that we have in scope today of our talk, I'm going to only address 2 of those. First, the unmanned aircraft, and second, sensors and payloads that they may carry. Now, the unmanned aircraft is the part of the system that people most often see, and it is the one that is most readily recognizable. So when we think about, excuse me, when I'm looking at unmanned aircraft, there are 3 basic types of unmanned aircraft. And the categories for unmanned aircraft are typically divided by the mechanism or the manner in which an aircraft flies. So the 3 categories are the fixed-wing aircraft, a transitioning aircraft, and a vertical takeoff and landing, or VTOL aircraft, which you'll hear. Within the VTOL, we're going to divide that into 3 subgroups: the multi-rotor copters, single-rotor helicopters, and a ducted fan aircraft. Now let's look at each of those categories individually. First, the fixed-wing aircraft. Here we see 3 commercially available fixed-wing UAS. I do want to highlight there's an S before UAV in this, And when I say UAV, we're talking about the unmanned aerial vehicle. So it's the vehicle or aircraft portion of an overall system, or a UAS. The small s before the UAV indicates that it's a small UAV. In other words, it's under 55 pounds, which is the limit that Part 107 put on aircraft that it can fly in our national airspace without additional permitting. That's something Thad's going to address later today. The first image we have is of a Trumbull UX-5. It's a delta wing aircraft. It's a pusher aircraft, typically equipped with either a multispectral camera or a high-quality digital imaging camera, which is used for photogrammetry. The second image is of a Dell AirTac DT-26. This is a larger aircraft, and it's kind of similar to, you can kind of think of it as the C-5A cargo aircraft for unmanned aircraft. It has a much larger cargo bay. It has an extended range, and in Europe, this is operating at up to 20 kilometers away from its original launch site. That's not allowed in the United States, and that'll address that within the regulation. But here it has multiple payloads that it can carry. It has extended flight times of well over 2 hours. And then the third aircraft on the bottom is an aircraft called the Lancaster by Precision Hawk. They're a well-known drone manufacturer in the United States, and as you can see, it actually has a modular payload bay, which allows multiple sensors to be hot swapped, plug and play with that aircraft. This aircraft flies for between 30 and 40 minutes. It does photogrammetry, it can do LiDAR, it can do multispectral, and I believe they actually have a hyperspectral unit that they're working on. The second type of aircraft that we mentioned is transitioning UAVs. Transitioning UAVs typically have been used in more advanced and sophisticated aircraft. You've seen it in military applications, but they're beginning to find an advent into commercial UAS. The unique thing about a transitioning aircraft is that its initial takeoff is that of a VTOL. So in other words, it uses these 4 propellers to lift it off the ground to get it airborne and begin moving forward, and then its main propulsion system takes over and it flies in horizontal flight like a fixed-wing aircraft. The aircraft we're looking at here, the ALTI transition, has electric motors that lift it, and then it has a fueled engine that drives it towards normal flight. One of the unique features of this aircraft is that the main propulsion engine powers the battery system, so that even if you fly for a long period of time and use up most of your battery capacity in taking off, it charges that battery so it's fully charged as it comes back and lands. These aircraft can be significantly capable of producing long duration flights, up to 6 hours, and carrying payloads that are significant payloads, significantly heavy. A third type of unmanned aircraft are the vertical takeoff and landing aircraft, VTOLs for short. So VTOLs afford an operational flexibility in tight operating quarters, and they have the ability to stand and stare, and they also afford a slow flight speeds. They accommodate multiple sensors and allow for flight close to objects. Because they do not employ a wing for lift, they must provide all of their own lift, which makes them typically have shorter flight times. In this category, the ubiquitous quadcopter, and the one we're showing here is the DJI Phantom Pro 4. It's one most of you have probably seen people purchase and flying around. This actually is quite a capable small aircraft. It's most commonly used for photogrammetric and for photography and for video usage. The aircraft below that is also a DJI multicopter. It is a hexacopter. It's Matrice 600. This is a very capable professional level aircraft by DJI. It has triple redundant GPS IMU system where it's constantly measuring the solution of where that inertial management unit and guidance system of the aircraft is, averaging those and taking the 2 most stable solutions and using that for its current positioning. It has a payload capacity of up to 12 pounds and typically flights in the 25-minute range when fully loaded. For single rotor VTOLs, also we would call them helicopters, here we have an image of the Pulse Aerospace Vapor 5500. True helicopters are both more complex and efficient than multirotors. They typically have longer flight times and may be equipped with a variety of sensors. This image I mentioned is of the Pulse Vapor 55. The CEO of Pulse, Aaron Lessig, will be here this afternoon later and talk about this aircraft and capabilities it has. In this case, this aircraft is equipped with a dual sensor setup. It has a very capable Regal VUX1 LiDAR and then 2 digital cameras, so it allows it to collect at the same time both digital imagery as well as a LiDAR data set. We'll talk about that if you're not familiar with LiDAR here in the future. This aircraft weighs the full 55 pounds to the limit. Its operational flight times are basically fully loaded in the 45-plus minute range. One additional type of VTOL that I want to highlight, which you will likely not encounter, is that of a ducted fan. The top is images of a Honeywell aircraft they call the T-Hawk. They call it the flying garbage can. Extremely loud. It has 2 counter-rotating fans that lift that up, and it looks like R2-D2 for those of us who kind of had old Star Wars histories, you know, flying through the air. Reference Technology up in Broomfield makes the aircraft below. This is a large aircraft, and one of the challenges with it is even though it has relatively long flight times and heavy lift capacity, it exceeds the 55-pound small UAS limit, and it also is bulky and difficult to transport. You'll likely not run into those. So let's think about capabilities of aircraft. As you consider a UAS, you'll encounter a variety of systems. There are literally thousands of systems available on the market today. Each has its own physical and flight characteristics, including its weight. GTW is the gross takeoff weight. That's total weight all in with fuel, sensor, and everything when that takes off the ground. As we said, UAS requires there to be 55 pounds or below to fly as a part of Part 107. Its physical size or dimensions, its power source, its range of operation, its endurance, how long can it stay in the air, its wind tolerance, what happens when you're in a windy operating condition, its operational flight ceiling, how high can it fly efficiently and carry its payload, where does it lose lift and become unstable, its cruise speed, the C2, what are its command and control links, how sophisticated are they and how reliable are they, the sensor types that it can carry, the sensor capacity it has for managing and controlling that sensor while it's on board, and then what type of data links do we have? Because sometimes we have a long command and control range. It might be 2 or 3 miles, but the data link is only good for 700 yards. And at that point, if you need a live data feed, the distance aircraft can fly is irrelevant to you. Some systems are much more capable and reliable than others. Because of this, it's increasingly important, especially as one begins to consider carrying the expensive sensors that require precise flight planning and operational control to generate highly accurate and precise data products. Now let's look at the second thing or element that I said we were going to talk about is sensors and payloads. We have 3 basic, we've looked at the 3 basic types of aircraft, and let's see. We want to also look at not only the payloads, but the type of data they'll provide. As long as we have a reliable and capable UAV or aircraft, what makes the biggest difference for operators is the type and capability of the mission sensor. So the aircraft has in itself a variety of sensors that allow it to fly, help it navigate, and help it know where it is, and stay navigating in a safe, effective, and compliant way. Now we're talking about a sensor that's mounted on the aircraft to do a job that's either going to solve a problem for you or make you money. Sensors that can be a benefit to mining and agriculture include, and probably the most frequently available sensor, or the sensor that's available most often today in UAS, are digital cameras. They provide a variety of functions, but their most frequent function is imagery for photogrammetry. I know a lot of you, some of you may understand what photogrammetry is, some are not, so I'm going to go ahead and define it for you. But photogrammetry is a science of making measurements from photographs. So what happens is the aircraft flies, and it takes a a large number of highly overlapping images. In the picture you see on this slide, those, you can see the overlapping of the images, and then where the center of the sensor, in other words, the sensor plate of the camera was located at the point the picture was taken, is represented by the blue-green ball. What happens is all of these highly overlapping images then are put into a computer program that then matches the pixels and tries to identify what is the same object in this picture that was the same object in this picture, what pixels represent that, and what unique geometric and algebraic locations are required in the simultaneous equation solution to get an X, Y, and Z for that exact pixel in space. I know that's anyway, that's kind of a quick definition of what photogrammetry does. What that actually does for you is it creates, every pixel now has an X, a Y, and an elevation, a latitude and longitude and altitude, so that now we can create what we call a digital point cloud. We now have points that represent the three-dimensional surface over which that aircraft flew. So UAS, unmanned aircraft using photogrammetry, is a significant development for industry requiring high degrees of accuracy in mapping of land and physical assets. It includes things like mine stockpiles, pipelines, utility corridors, highways, construction projects, anything in which you would have a land surveyor involved, photogrammetry can play an active role in. They can deliver spatial accuracies in the 2 to 5 centimeter range, so somewhere between smaller than a ping pong ball to a little larger than a golf ball. To be able to know where you are on our world with that level of accuracy is a phenomenal achievement and advancement in technology today. They can fly and process in a day or two what would take literally weeks for people and surveyors in the past to provide. At the left, what I want you, so again, this is an image from Top Gun. This shows the photo mosaic, in other words, all those small images stitched together. This represents a digital point cloud, so that once those points are calculated, you can see they now have elevations, it's no longer flat, and they have colors associated with those pixels. What they've now done, this is called a DSM, or digital surface model. They now actually have a three-dimensional surface model, and those different colors, the blue, green, yellow, and red, represent different elevation, gradient elevation changes. And then the bottom layer actually is the image of the topographic map that's been generated from that photogrammetric process. Another thing in common use of photogrammetric processes is volumetric and calculation of bulk materials. Anything that's a bulk material can be used, you can use photogrammetry to calculate an irregular volume. So if you have a pile of grain, if you have a pile of ore, if you have a pile of gravel, if you have whatever you have a pile of, you can take a picture of it and you can calculate a highly accurate, within plus or minus 1% accuracy, the volume of that. Also, current technology is now allowing those images to be uploaded, processed, and data to come back to you. One of the good things in the mining, I come from the mining sector, is that it's very difficult and very dangerous to put surveyors up on the top of some of those large muck piles or those large ore piles, and they change and they're not stable. We can now put somebody up there and we can actually have a much more accurate representation of what is actually on the ground there and a representation of the change over time. What you see in this image is a process developed by the group called Propeller out of Australia, in which they have flown this pile, they've reflown it, and now what it shows you, the green areas are areas in which material was added, the red area is areas in which material was removed, and the net difference is a negative 5,017 cubic meters. So for a mining company or an aggregate company that needs to reconcile month to month what their ore reserves are, it becomes incredibly useful and helpful. Another type of sensor that becomes really helpful, especially within the agricultural sector, is multispectral sensors or a multispectral camera. Frequently, multispectral data is used to generate what we call an NDVI imagery. An NDVI is an acronym for Normalized Difference Vegetation Index. Just remember NDVI. And it's a measure of reflectance of a plant in a multiple wavelengths. It's a good measure of plant health and plant stress. As you see from this diagram from Agribusiness, the reflectance coming off of that leaf, if the plant is dead versus whether it's in stress, whether it be from water or lack of nutrients or from insect infestation, is different versus the reflectance of a very healthy plant. Here's an image of, or an example of some NDVI imagery, and it also shows one of the benefits of a drone-based imagery. On the left, you see satellite imagery, and you'll see that the resolution is in terms of meters to tens of meters. So the pixel size covers a very large area. For this farmer, if he can actually have the resolution that's represented by the image on the left, which is by a multispectral drone, delivered by a multispectral UAS or drone, they can now see exactly what's going on, where it's gone in the field, and the resolution of that images comes down into the centimeters or tens of centimeters. So you can actually begin looking at individual plant health and plant structure and biomass. Another sensor that is is becoming more influential with unmanned aircraft is a hyperspectral imaging. This has typically been, it's had a significant advent as a result of the miniaturization of the technology. In hyperspectral imaging, light is reflected from objects that have a dispersion, it's dispersed into its spectra. And then the intensity of certain precise spectra bands are measured. The intensity values are unique and characteristic and give the material a unique spectral signature. In other words, every substance, every material, every compound, every plant, every person, every drop of blood has a spectral fingerprint. And if you know what that fingerprint is, and you fly over this, and you collect all that data, you can mine that data for those specific fingerprints and see when they're present and if they're not. Similar spectral fingerprints can be used in mining to do open pit or pit mapping and identify mineral alteration zones. Or in a pipeline, they can monitor for leak detection or the presence of chemical compounds. Or in agriculture, they can look for a specific plant species or soil component or chemical compound or the presence of a disease or insect, because each of them have their own unique spectral signature. Another sensor that can be useful for UAS and is commonly on board many UAS is the EOIR, or electro-optical or infrared camera. It provides live video streaming through the UAS data link. These typically are best for observation of dynamic environments. They can be used by first responders for search and rescue, fire, emergency response, security, and they can be used for situational awareness. In one particular application I know of, there was a mining company on a different continent that was having challenges with subsistence mining and coming onto their property, but they didn't want to be surprise people and create a problem with that encounter. They flew with an EOIR sensor. They found out where the people were. They found out what the number and kind of what they were doing, and then they actually went and initiated a sustainability effort to help engage these people, move them into a different region, and avoid a direct conflict with them. LiDAR. LiDAR creates a point cloud. In the last few years, one of the significant advances has been the miniaturization of LiDAR units and allowing them to be carried on UAS. So LiDAR stands for light detecting and ranging, and it's a remote sensing method that uses light from a laser to measure ranges or variable distance from the sensor itself to the surface of the Earth or an object being scanned. These laser pulses are combined with other data recorded by the aircraft's navigational system and then are processed to generate a precise three-dimensional point cloud showing the shape of objects being scanned, creating very highly accurate dimensional maps. So we talked about a point cloud being generated by the photogrammetric process. This is a different, I'm on the wrong slide. This is a different process generating a point cloud. In this image, you can see the specific laser points in which the laser went out, went down, hit the ground, came back, and then was recorded. Its X, Y, and Z location was located. Here you can see clearly it's very helpful for identifying topography and for infrastructure and vegetation. One of the amazing things about LiDAR, and the uses that we use this very highly in our business, is that we can go in, we can then classify things above ground and the ground, and we can subtract all the vegetation. So if you're a construction or mining company, you can get an accurate representation of what the ground surface is, so you know much more effectively what you're going to have to do to prepare and to do cut and fill and design model. One fun new sensor on the market, which has been, well, fun, they might not say that, but is a coronal camera. And I don't know how many of you are aware of this, but this is a camera that enables you to detect arcing of high voltage equipment prior to a system breaking down or failing. It looks in the ultraviolet set of the spectrum, and what it does is it has an inline high definition video as well as this sensor. And when you turn it on, you can see the arcing looks like a snowball. It has a photometer that measures the number of photons that are being emitted by that source, and you can basically calculate the amount of leakage. You can turn off, and now you have a high-resolution video image where you can geotag that location, say, here it is, where in X, Y, and Z, here's what the actual failure looks like. We have a cracked sensor, we have a loose connection, here's what we need to have for the crew to go out and mitigate that. And can it be done in a normal maintenance cycle, or is it critical and creating instability and something we need to address right away? That's just a few of the sensors that are available on UAS today. So when we think about putting this all together, we're looking to get the system to work in a harmonious way to produce the desired result. And the result is the process, the resulting process is called system integration. So we have the aircraft, we have the sensors, and all those other elements we talked about all working together to form a UAS, an unmanned aircraft system. Just remember that not all sensors are suitable for all platforms. Because of their weight and their size, some of them require power consumption, some of them are very sensitive to vibration, so they do better with a fixed-wing aircraft than they do with a VTOL aircraft. Some of them need a certain type of, have a long span that they are gathering data over, and sometimes flight capabilities of an aircraft limit that. Others require a slow speed, and so to have a fixed wing, sometimes you cannot fly at the speed to allow that data to be collected. And others have an operational standoff distance. They are effective at 30 meters, where you can't fly a fixed-wing aircraft without hitting a lot of obstructions, typically to 30-meter operational elevation. The key is for you to think about the design and have the end goal in mind, which is what is the unique operational environment you'll be in, and what type and quality of data is needed for you to make the decisions that you need to make. Generally speaking, I think there's some broad benefits that whether you're in agriculture, mining, or infrastructure, UAS provide. First, I think it's safety. They get people out of harm's way. Second, it's efficiency. They minimize operational disruption. One of the key things on a large open pit operation is you have large trucks running through at high speeds through an area, and they can't see small vehicles and people. That's where a lot of those accidents occur. So by putting a drone in place, it doesn't interrupt the workflow, and it doesn't put people in those close proximity to those vehicles. Temporal frequency, it allows you to fly as frequently, as often as you need to get the data you need to make the decisions you want. Flexibility, it gives different sensors and the ability to have a variety of data types. Responsiveness, it allows you to respond to changing conditions, and it allows you to have an emergency response if you have a condition arise that requires action. It gives perspective and innovation. Because you have a new vantage point, you can ask new questions, and you can draw new conclusions. And analytics, because of the new analytics that are being developed, not only do we have data and we have what we have, but now we have a lot of the so what do we do with this data as a result. UAS, honestly, are making a major impact on a variety of fronts, including productivity, cost, and efficiency. So what I wanted to look at briefly then is just a list of areas in which and ways in which UAS can benefit each of our sectors. I'm not going to read all of these. You'll have the PowerPoint. You can use them as food for thought. But some of the ones I want to highlight is for agriculture, you have real-time crop monitoring and scouting. You know exactly what's going on in your field, in every part of your field, and if there's a problem, you can go out and ground truth it and figure out what you need to do. It creates a clear means by which you can measure crop progression and health, where you need to add water, where you need to add fertilizer, where you need to deal with infestation. It allows you to field map so that you can now map the topography of your field, and you can more effectively deal with sedimentation, runoff, drainage, and water usage. It allows you and gives you alerts to pests, weed invasion, drowned out zones, bacterial or fungal invasions and infestations, and spoilage areas. And one of those we haven't had time to really get into, but UAVs are being used for livestock management, livestock tracking, livestock identification, and lost animal finding. That's not the right word, but in the mining industry, here's a few of the highlights that I would say are interesting and useful and currently being employed in mining. Security perimeter section, I talked about that earlier. Mine planning in both short, medium, and long-term applications. Automated navigation. Aaron may talk about this later, but they were using a LiDAR unit to scan the mine every morning, processing it, loading it into their automated truck system, and now they could take those big trucks, run them on narrow roads, and not run them off the road because they knew exactly to within the centimeter what was actually the mine surface looked like. And so they can use that for an accurate automated navigation system. Stockpile volumes and inventory reconciliation. Tailing dam monitoring. Leach pad design, management, and optimization. And one of the things we're working on currently is proving out the technology and workflows. We've been working with CDOT in flying some of the very sheer hazard zone canyons to identify rockfall zones and be able to keep people out of harm's way, not put them on the slope unless they need to. For infrastructure, some of the arena, again, some of those same things we've talked about in the other areas are applicable here, but I'd like to highlight inventory management. We worked with an organization that took over a contract for a nuclear power plant build, and there was stuff strewn everywhere, and they were having a hard time tracking what was where and why, and what were they actually getting as a result of taking over the contract. By flying that area with high-resolution imagery, they were able to classify what's there, how much is there, and they were able to then build out what is their sorting, what's their process to begin to reorder that site to make it effective. Monitoring inspection of pipelines, transmission towers, wind turbines, and flare stack inspection. Fugitive gas emission. What's happening coming out of pipelines, out of tanks? What about methane emissions? And how do we mitigate against that? Is it present? If it's present, what are the concentrations? Vegetation encroachment monitoring. This is a big one for power line corridors. We can run a LiDAR unit, we can create a baseline map, and then we can run again, and you create hot zones, which identify where encroachment is, what mitigation needs to take place, and they can focus their energy and their resource on those locations. And then emergency assistance and management. When you have an event, what do you need to do to equip yourself for ingress, egress, prepare? What type of damage or problem has occurred, and now how do we get the right equipment and the right people and the right trucks in the right place so that they have a minimum amount of time in repairing and restoring service. In conclusion, I would say that UAS are significantly impacting each of the industry sectors that we're highlighting and talking about today. The UAS technology is evolving rapidly, and that UAS will only increase its impact in these arenas in the future. One caution I would give you, having worked in the industry for a number of years, is that acquiring quality data is challenging in a challenging operational environment is harder than the UAS marketing hype leads you to believe. We hear regularly, it's easy, you can take the person out of the loop, you push a button and up it goes. Well, the truth is, in the 2 years that we have been operating commercially, we have not had one flight plan that I can think of that we planned in the office when we got on site that we were able to fly it without adjusting it. because of aerial obstructions or things. Google Earth is just not up to date. And the maps are way off. They can be 30 meters off in their direction. And so you end up flying into things and running into objects, or you start getting electromagnetic interference. All of a sudden your flight control system starts going haywire. There's a variety of things that you need to consider. And one thing that's happened when we've done training around the world and we've done in helping stand up organizations, they've come back and asked us, would you be willing to fly for us and come alongside us and help us understand whether we want to do this internally or whether we want to contract that, because we want the benefit that this brings, but we're not sure we want to have the overhead of an entire program that we host internally. Finally, after all, you never want to be that person. I don't know how many of you are familiar with this, but last week they said there was a person, they said a white guy in a white van who had a drone flying and it flew into a high-tension power line in Mountain View, California, knocked out power to 1,600 people, and some of them were actually Google executives. So they got on the phone, and there was a bit of a stink. But you don't want to be the one that the police force is coming to look for. This is a picture of the burnt crisp remains of the drone that went up. So thanks so much. I really appreciate your time. I know that was a bit of a whirlwind tour of unmanned aircraft. There was a lot of stuff we covered, but I hope that kind of gives you an idea of what aircraft are available, what are some of the sensors they can carry, and then what are some of the applications that might happen in the industry sectors we're talking about. Thanks.
Thanks, David. We're going to go ahead and switch the PowerPoints for this one presentation, and Thad Lightfoot will be up to present.
As David said, you don't want to be that guy that the police is looking for. You don't want to be that guy that the FAA is finding either. And so we need to talk a little bit about the issues that you might that we've seen in the last year in particular. With the advent of the Part 107 regulations that David referenced, and also the Section 333 exemption that we'll talk about a bit. How do we get here? The first question is you're dealing with aircraft flying in the national airspace. And FAA regulates aircraft flights in the national airspace system. And FAA's view of the national airspace system is that goes everything from a couple of inches above the tops of your grass in your backyard to 60,000 feet, which is about the effective height of commercial aircraft flying internationally. Actually, the Concorde flew at 60,000 feet. It's been gathered to its reward. Most airliners fly from 35 to 40,000, but the national airspace system goes up to 60. So are UAVs or UASs or drones aircraft? Absolutely, they are aircraft, and they are aircraft operating in the national airspace system. And if that is the case, absent an exemption or absent the Part 107 regulations we're going to talk about in a moment, in order to operate that aircraft, you would have to have a certified and registered aircraft, which means it's got to go through FAA airworthiness analysis. You'd need a licensed pilot, which means you need both your pilot's license regarding aeronautical expertise and a license regarding your health, and operational approval of the drone. Again, that airworthiness. And as I said, the FAA regulates the national airspace system even at low altitudes. So all of this is why Congress in 2012 in the FAA Modernization Act created an exemption in Section 333 that we'll talk about, a process for UAVs or UASs or drones, drone flight. And the FAA ultimately promulgated the small UAS rule in August of 2015. Just for you lawyers online and in the room, the legal authority that FAA has for the national airspace system comes from the Air Commerce Act of 1926, from another statute, 49 U.S.C. 4103, which says that FAA is charged with regulating areas of airspace in the United States. And a Supreme Court case, an old one, U.S. Versus Cosby, which rejected the idea that a property owner owned everything on his property from hell to heaven, from all the way depths of the hell to all the way up to heaven. The court said, no, that's not the case. We're not going to have a trespass for every international flight that flies over your house. A landowner occupies at least much space above the ground. He's got that ownership of the ground that he can occupy or use, and then a buffer space. And again, more on that in just a moment. Here's a graphic of the National Airspace System, and I won't spend a lot of time on it, but just so you see it there, it's divided in a series of classes. More on that in a moment. The most heavily regulated class is Class A, from 18,000 feet to 60,000 feet. FL 600 is that means air pressure of an altitude of 60,000 feet. Most drone or UAS or UAV activity occurs in Class G airspace, which is typically below 1,200 feet, and in most cases below 700 feet. And again, in most cases when drones are flying, they're flying around 400 feet or thereabouts. And again, more on that in a moment. I call this slide Guys and Drones, but this is a question of hobby aircraft. Hobby aircraft is interesting. The FAA, under the 2012 Modernization Act, stated that they have no authority over model aircraft or over hobby aircraft, which is interesting because then just a few years later, FAA promulgated regulations that required tail numbers on all aircraft, including hobby aircraft that were above roughly a half a pound, 250 kilograms, and less than 55 pounds. More on that regulation in a moment. The other tension here is what FAA considers commercial use, which is what we're talking about, and what FAA considers hobby use. Hobby use is going out in your backyard and flying around at the end of a stressful day. It's recreation. It's the FAA speaks of it in terms of refreshment of strength of spirits after work and a means of diversion, right? So you're out there having fun with your model aircraft. That's what's going on. If you are flying a UAV for any purpose, if for somebody else or for yourself, and it's not for recreation, then you are, under the FAA's analysis, involved with commercial use. And what does that mean? It means that you're going to be regulated. And interestingly enough, money doesn't need to exchange hands. Again, more on that in just a moment. As I mentioned a moment ago, FAA did require tail numbers for hobby aircraft, but not anymore. The D.C. Circuit about a month ago said, FAA, remember when Congress said in the 2012 FAA Modernization Act that FAA didn't have any, may not promulgate any rule or regulation regarding a model aircraft? Well, guess what? Congress meant what it said. The language is pretty clear, and you don't get to put tails on or numbers on model aircraft. If you go on FAA's website for the last month, they've been saying they're considering their options. I don't know what that means. But this raises the tension, really, and the unresolved tension, and this is where I think if there is additional litigation, this is where it's going to come, the tension between what constitutes commercial use and what constitutes hobby use. The D.C. Circuit obviously didn't get into that question at all, but that's the real rub, I think, potentially in future litigation. Okay, so about a year ago, before the Part 107 regulations, all we had was the Section 333 waiver process, which was created under the FAA Modernization and Reform Act of 2012. That process was cumbersome, but as you see in the slide, you need to identify a pilot. And by the way, that meant a pilot. That meant somebody with a manned aircraft pilot license. You needed to submit an application. They were complicated. They involved a lot of paper. Often lawyers were involved. some lawyers were charging flat fees of $5,000 or $7,500 to submit them, but they were complex. Then you waited. It took a long time for FAA to evaluate that Section 33 waiver process. Then you got a registration number, and only then did you get to fly. And you had to file a notice of airman and send it to the FAA, notice to airman and send it to the FAA. FAA also recommended that you keep a logbook. So although Section 333 was designed to provide some flexibility for UAVs, so you didn't have to go to, it really was a waiver of the airworthiness requirements that FAA applied. It was complex. One thing to remember, and we'll talk about the 107 process in just a moment, but Section 333 is out there. Sometimes when I go to these presentations, people say, oh, well, 107 has really supplanted Section 333. That's not true. So if you have a circumstance where you can't get a waiver, you want to do something under Part 107, and you can't get a waiver to do that, then Section 333 is still available and provides a little more flexibility. It just takes time and can be a little more expensive. Again, that's what you typically did after you filed your Section 33 petition. You waited. Okay, well, so why not just fly? Why not just get out there and go out and have a good time and run into a power line or something? Well, FAA Enforcement is one reason, and the thing that really I think sent shockwaves through the industry was the Skypan international fine. Before Skypan in about 2015, 2016, there had only been 24 fines against parties flying UAVs or UASs without exemptions or without airworthiness certificates. And the largest fine was $5,500, not too much. Then Skypan flew 61 flights in Class D airspace, which is around 10,000 feet, but over highly populated areas and very close to major airports in Chicago and Detroit. Not a very good thing. They did that without a Section 333 exemption. They flouted FAA, really. FAA was very unhappy and proposed a $1.9 million fine. $1.9 million. That fine is still pending, but that's the reason you just don't go out and fly. That's the reason you worry about a Part 107 Part 107 or a Section 333 exemption. Here, I'll give you another example that comes from my home state, Minnesota. How many of you remember the Minnesota dentist that got into a whole bunch of trouble when he was out on safari and killed Cecil the Lion? Okay, well, that happened in 2016. So there were a number of people. He was in Eden Prairie, and so there were a number of people in Eden Prairie that didn't like that he had killed Cecil. And so this group got together, and as you can see on the slide, this is a protester. This is an outline of Cecil, and you can see courage there, and there's an outline and people around his mane. He wasn't one of the organizers, but he was a friend of an organizer, and he said, "Hey, I've got a drone. You're going to do this. Would you like me to take pictures of what we've got here with Cecil for your use?" And the woman who organized the protest said, "Sure, that'd be great." So he flew over dutifully and took this picture. This is one of the pictures that he took. But he did it without a Section 333 exemption. This is June of 2016, before the Part 107 regulations that we'll talk about in a minute came into place. He was fined $55,000 by the FAA for taking pictures of Cecil the Lion. Again, he's appealing the fine and the like, but again, this is the reason you don't just get up and in the morning and fly around with your drone or your UAV without thinking about the regulatory consequences first. The real game changer and as David was speaking, the real game changer in the regulations of UAVs came about a year ago on August 29th, 2016, when FAA's regulations under 14 CFR Part 160 went into place. This is the small UAV regulation, and small being, as David mentioned, under 55 pounds or 55 pounds and under. So this is an alternative for smaller UAVs, so you don't have to go through the Section 333 exemption process, and you can, in fact, fly so long as you meet these regulations. Really, there's nothing more to do. It's essentially a permit by rule under Part 107. So a couple of operational limits. Less than 55 pounds. That's with all the sensors and everything you can hang off the UAV or UAS, and that is at launch. So less than 55 pounds, 55 pounds or less at launch. You also can't include a sensor or any other accoutrement that will actually impair the ability of the drone to fly. By the way, there is a waiver process to waive some of these operational limits. Some of these operational limits are waivable, some are not. The weight limit is not waivable. If you want to fly a drone that is over 55 pounds, you need to go under the Section 333 exemption. Second was the Part 107 had to be within the aircraft had to be within a visual line of sight. The remote pilot in command, and that's a new term, that's the drone operator, more on that in a moment, has to have that drone within his or her visual line of sight while operating. With corrective lenses, which is what I wear, usually in a drone that is close to 50 pounds, that visual line of sight is 2.5 to 3 miles. So we're not talking about 30 kilometers as you can do in Europe. And you can waive the visual line of sight requirement, although those waivers have been less. There have been fewer of those. But if you don't want to go for a waiver, it has to be within visual line of sight. Daylight operations, which means daylight or civil twilight, which is 30 minutes before official sunrise or 30 minutes after after local sunset. The daylight operation waiver can be waived, and it's the single most common waiver we see under Part 107. There are about 985 as of yesterday when I checked the website. There were 985 waivers that FAA had given under Part 107, and most of them were for the waiver to allow operations at night, daylight operations, daylight operation waiver. And height and speed, 400 feet high and speed of 87 knots. And again, those are also operational provisions that can be waived. The other interesting thing about 107, and it's important for infrastructure if you're looking at inspecting stacks, for example, it's 400 feet or within 400 feet of the top of any structure that you are inspecting. So if you've got a 300-foot stack, you can go up to 700 feet as long as you're within 400 feet of the top of the stack. Where can you fly? I said you'd see the National Airspace diagram again. So where can you fly under Part 107? Well, again, mostly in Class G airspace, that is below 700 feet, mostly in an uncontrolled area that is not near airports. If you are near an airport in Class G space, or if you are in Class B airspace or Class C airspace, or really even Class E airspace that's near an airport, as you see on this diagram, you're going to need advance approval by air traffic control before you fly, even under 107. It's hard to get. FAA is very concerned about getting UAVs, UASs near airports. I represent the Metropolitan Airports Commission. I have for a long time. That operates Minneapolis-St. Paul International Airport. I was in their offices last week, 2 weeks ago, in a conference room. This sign was sitting on an easel. These signs are going up all around Minneapolis-St. Paul International Airport, the prohibiting drone operations on its properties. Airports are very, very concerned about drones. I mean, they're concerned about birds. right? And so there's a great deal of, they take a great deal of effort to minimize attractive nuisances for the birds, minimize ponds and the like in the areas so you don't have bird strikes. Imagine what, and you know, a bird is relatively light, a few pounds. Imagine if a 50-pound drone went through your jet engine as you're when you're taking off at Minneapolis-St. Paul International Airport. That could ruin your whole day. And so the airports are very, very concerned about drones near airports. Okay, so I said under Part 107, the regulations create a new remote pilot in command. So you don't need a pilot's license anymore to be a remote pilot in command. Now, under Section 333, a pilot in charge has to have an appropriate airman's certificate. But that's not the case under Part 107. Part 107 simply requires a person to demonstrate aeronautical knowledge by passing an initial aeronautical test at an FAA-approved testing center. And by the way, if you hop online, you'll see lots of people ready to train you to pass that test for $99.95 or $150 or the like. So there's a little cottage industry on training people to pass that exam that's popped up. You have to be at least 16 years old, of course, vetted by the by TSA, by Transportation Safety Administration. And then after you get the certification, you have to retest every 2 years. If you hold a Part 61 pilot license or Part 61 certificate, other than a student pilot, you're automatically you can automatically be a remote pilot in command after TSA vets you. Right now, if you hold foreign UAS pilot certifications, FAA doesn't recognize those, and you would still have to go through. You'd still have to go through the testing. You also have to demonstrate that you're proficient in English, can speak write and understand English. There are a few other operational limits that I want to mention under Part 107. No operations from a moving aircraft, no operations from moving vehicles over sparsely populated areas, no carriage of hazardous materials. This is an important one, although it can be waived. No operations over persons other than a remote pilot in charge, unless those persons are in a structure that's protected by a roof. Why? Because there's concern that if the UAV falls out of the sky, it could hit somebody. So you don't want to be flying it over people unless you've got a specific waiver. There are other restrictions that aren't, and some restrictions are waivable. Daylight operation has been the single biggest waiver. You can get a waiver for operation from a moving vehicle or aircraft, but not to carry property for hire for somebody else. So the Amazon drone flying to your house is not yet available under Part 107. And some portions aren't waivable, and the biggest one there is weight. If you're going to fly a UAV that's over 55 pounds, you've got to file a Section 333 application. And as I said, there are about 985 waivers that have been granted. Most have been for night operations, most in Class G airspace, but not near airports. Okay, so David talked a great deal about ag operations. The only thing I want to mention here is that under Part 107, you can't conduct what are known as agriculture aircraft operations. So you can't dispense anything, even water, from a UAV or UAS under Part 107. The moment you do that, you've got an agricultural aircraft operation, and you've got to follow different regulations. Section 333 exemptions might be available, but no hazardous materials carrying. So fertilizer might be an issue. Infrastructure operations, again, just remember that we're talking about 400 feet above a structure. There's also some cloud limitations, so you want to take a look at those as well. But and David talked a little bit about this. There, air and water quality monitoring is being done, and other regulatory compliance on the infrastructure side. Pipeline inspections. because under Part 107 you can actually hand off drones to different pilots in charge as long as they can still see the drone and are in communication, or if they have a waiver out of line of sight. So FAA is trying to make it easier to do long-range, long-run infrastructure inspections. Mining operations have an advantage because they are actually remote. They're far from airports and population centers, and so in some respects they have more flexibility. And you heard David talk a little bit about the use of UAVs, UASs in handling dangerous inspections under Part 107. I want to conclude by talking about two things: preemption, state regulation, and then some common law, potential common law issues. There's certainly, and Jamie's going to talk a great deal about privacy issues, but one of the concerns here is privacy rights, and when UAVs are inspecting facilities, especially with utilities that might have easements, do the utility companies need special language to deal with that? How do they do it? It leads to the whole question of federal preemption and UASs. There is no, Congress vets FAA with the authority to regulate in the national airspace. We talked about that. And FAA typically has authority and will preempt state regulations that deal with operations, equipment, or training regarding aircraft. In the comments on the Part 107 rule, a number of parties said, please issue a blanket preemption under 107 so we don't have to deal with these patchwork of state regulations and how they fit and whether they're preempted or not. And FAA opted not to do that, in large part because local land use has been a local issue all along, and there's always been this tension between FAA regulation and local land use. So there's no blanket preemption, but clearly the FAA in a general counsel's memo in December of 2015 said if there are restrictions on operations, equipment, or training, those are likely to be preempted. But land use and zoning, privacy, trespass, all of those issues are not necessarily subject to federal regulation. One more thing I wanted to add on this question of infrastructure. The 2016 FAA extension had some extensive discussion of infrastructure issues in it. And one of the things it said, first of all, it encouraged FAA to establish a process to allow more outside line of sight inspections, beyond visual line of sight inspections for pipeline and other infrastructure. But it also recognized that energy and mining companies aren't just using drones, they're also concerned about protecting the nation's critical infrastructure from drones. And so that legislation, in that legislation, Congress directed FAA to establish a process for applicants to petition the FAA to either prohibit or restrict operation of UASs in close proximity to fixed site facilities, which were defined as critical infrastructure, energy production and transmission lines, oil refineries and chemical facilities, amusement parks, because you're dealing with a large number of people congregated in a single place, and other locations that warrant such restrictions. And FAA has moved forward with some of these restrictions. They've prohibited drone flights over military facilities nationwide, about 133 or so, and there are special rules. In the District of Columbia for drone flights. One more quick comment on state laws. There are a number of states that are getting into the mix here. The National Conference of State Legislatures has a very good website and tracks what states are doing, and you can take a look at it there. Nevada, for example, recently added transmission lines to its definition of critical infrastructure where UASs can't be operated. Utah has a statute that prohibits a person from intentionally using a UAS to harm or disturb livestock, so that is out there and something to be concerned about. In general, the state statutes either empower or regulate law enforcement use of UASs They prohibit the use of UASs over certain targeted facilities and infrastructure. They might regulate UASs in rural use, and then they prohibit certain UAS operations and protecting of privacy. And again, Jamie's going to talk about that a bit. Finally, with respect to the question of common law is still out there and something to be something that applies. There's no law of drones per se, but common law certainly can apply regarding drone flights. So trespass if you have a physical invasion into one's land, nuisance, disturbance of one's land without necessarily a physical presence. Those are torts that might be that you might see related to drones. Remember Cosby, property owners have an interest in what they can use on their property, and then also that low altitude buffer area that is incident to ownership. If there's an invasion in that area, and again, there's no specific height level, but if there's an invasion in the area, that's something courts are concerned about. Invasion of privacy and intrusion on seclusion, that's a tort, and Jamie's going to talk a little bit more about that. Strict liability and negligence. Negligence focusing on unreasonable harm, unreasonable action that leads to harm. Strict liability, ultra-hazardous activity. Is flying a drone ultra-hazardous activity? I don't know, but it's something that courts might consider. And then finally, one that is relatively new and that you may not have considered, and that's property damage to the actual UAS. If you destroy a UAS, you might be you might be subject to a tort for conversion. You might also have some civil liability floating around there as well. There's one recent case, it's a federal case, Boggs versus Meredith in the Western District of Kentucky in 2016, where the defendant in the case shot down a $1,400 drone which was flying over his property. And that looks like a state law tort. But the plaintiff in this case brought an action for intentional, trespass to chattels in federal district court, claiming that FAA had so regulated the area, the national airspace, and the drone was flying in the national airspace such that it created federal question jurisdiction. The court said, no, this is just a garden variety tort, and dismissed the claim, but something else to consider. So at least under Part 107, we can keep calm and carry on flying. That's my presentation.
Thank you, David. Thank you, Chad. Beth, just so we know where we are in the schedule, we're going to take a break now for 15 minutes until 10 o'clock Mountain Time. Again, the restrooms are around the corner for those of you that are here in person, and there is still some leftover food outside. So help yourself. Feel free to come ask the panelists questions during the break. That's why they're here, so do that. Take advantage of that opportunity, and we'll see you back here in 15 minutes. All right, thank you, and welcome back. This is the second session of our seminar today. Just a reminder for those of you that need CLE credit, both in person and attending by webinar, you need to fill out a sheet for each session. So even if you're in person, there's a new sheet there. Fill it out. Somebody will pick it up. Our second session today is entitled Privacy and Intellectual Property Issues in Precision Agriculture, Infrastructure, and Mining, and the presenter is Jamie Natzinger. Jamie is a partner at Dorsey Whitney, and for over 18 years she's helped clients grow their businesses by developing their brands, advertise their products and services, and launching cutting-edge online services and mobile applications. She has many clients in agriculture and in the energy industries, and she's advised clients in connection with the commercial use of drones, UAVs, and the legal issues surrounding developing and launching precision agriculture software systems and apps. She chairs the firm's cybersecurity, privacy, and social media practice group and has been named to the top 250 women in IT by a major publication and awarded Author of the Year E-Commerce USA by Lexology, which is the Association of Corporate Counsel. Jamie grew up on a dairy farm in Wisconsin and then spent 10 years in the San Francisco Bay Area. It's quite a difference. Before starting at Dorsey. And During your presentation today, I want you to answer the question, if you can, about my privacy concern. As I look out my window here over Cherry Creek, a couple weeks ago, I see the drone outside the window about office height, and I'm looking right at it out the window. So I've always wondered about that. How can that be?
Thank you so much, Robert. I'm excited to be here and join everybody today. Get started here. So normally when I start a presentation, I come up and tell a funny story or something to, get everybody laughing. But today I'm going to start with the concept of fear. It seems to be the underpinning of my current legal issues that I'm talking about today, both intellectual property and privacy. And Robert's kickoff was perfect. There might be a little bit of fear, and I think some of our senators have been buzzed by drones and may have some fear too. And you'll see that some of the legislation and some of the litigation that's happening right now, I think, is grounded in fear about drones. I sense that the emotions people feel about new technology, and specifically drones, kind of range on a spectrum. On one side, you've got people who I would consider giddy about new technology. They see all the promise. It's going to be so cool. It's going to revolutionize the world and help everybody. And maybe they don't think quite as much about the risks or the potential problems with it. On the other hand, you have people who I would consider frozen with fear. They have a lot of worries. They are concerned about all the bad things that might happen. They might pretend it's not happening. They might lobby for very restrictive laws, which we'll talk a little bit about today. And they may defer adopting something that actually would help their business quite a bit if they could get over that fear. So my goal for us today is to help bring everybody to the middle on that spectrum where we feel like we understand the risks that are there and we can maximize the benefit of this amazing technology without being frozen in fear or overly giddy on the other side of things. So it's one of the things I enjoy about being a technology lawyer is being able to understand the technology and the law and help bring my clients to that kind of position of empowerment and being able to use technology without too much fear. I've been working on drones for about 3 years now, on commercial use of drones, and this is a really interesting audience today because in the early days the uses for agriculture were very apparent, and we thought agriculture would lead the way with drone adoption. And now infrastructure and mining have figured out the amazing uses that they can have with drones, and they may actually even surpass agriculture. So it's a really exciting time. And many of the issues overlap, although some of them don't. So I'm going to try to cover something for everybody today. And I think back on some of the worries that I've heard from farmers about agriculture and drones, and it takes me back to the adoption of the tractor, which today nobody thinks of that as a controversial technology, but when the tractors came out, it was right around 1900. Right before that, the big technological evolution had been that people went from plowing with oxen. New plows were developed so they could plow with teams of horses. Then the tractor came out around 1900, and it was really unpopular. People didn't adopt it. Apparently it took 20 years for tractors to overtake plows with horses. So obviously we're much faster at adopting new technologies today, but it's not surprising that it might take a while for all the amazing uses and all the software to work perfectly with all the drones to do everything we want them to do. So as we go, both of my topics I think are sort of anxiety producing for people. They're worried about drones peeking in their windows, and they're worried about people taking data that they think they should own. I would like you to think about where you are and where your clients are on that spectrum of fear right now. Hopefully we'll be able to bring you to the center. The Obama administration, interestingly, was kind of more on the giddy end of the spectrum. They were pretty excited about drones, and as Thad talked about, they passed through the FAA, passed through the Part 107 exemptions more quickly than they typically have dealt with regulation, because I think they could see the real uses for it. And I watched in on a White House conference on drones last year, and someone from the Department of the Interior up there speaking glowingly about drones and all the safety uses they could see for those. And I know we have someone from that organization here today, so welcome. I'll be interested to see what this new administration does with drones. I will talk about one law that they've drafted just recently that the Trump administration has drafted. So I've been working on technology for about 20 years, and I've seen this cycle happen. The first step, I think, is people are really excited about a new technology. Then they become kind of wary because a few of the problems surface. And then eventually it gets into the mainstream like we are with tractors now. And people think like, well, what were we so worried about? It's fine. Now all of our legal agreements incorporate that new technology and everybody just thinks of it as a normal part of daily life. Right now for drones, I think we're in that wary section. And some of the laws I'm going to talk about, you can see they're really inconsistent. People are trying to figure out, some people are more afraid, some people are more excited. There's directly contradictory laws. So I think we're not at the end point yet where it's in the mainstream and this is all figured out. That's going to take a few more years. So let's get started. I am going to, David White spoke so well about our different industries that we're covering today that I'm going to go through these first few slides really quickly. These are more for if we didn't have that great introduction by him. So precision agriculture, for those who might be in mining or infrastructure, I think if I spend a second on this, it'll help you understand a little more about the ecosystem of technology. The idea is that you use technology, such as drones, to collect very specific information. You saw on David White's slides the very detailed level you could get on a farmer's field. And if you can get that in real time and actually analyze the data, then you could maybe make different seed choices for different areas of the farm. Or you could choose to apply pesticide or fertilizer in one area, but not another area of the farm, depending on the plant health. And the idea is that drones and this technology could eventually become part of a smart farm. You know, you hear about smart TVs and smartphones, and there are aspects of it that are coming into farming now, such as being able to connect a weather system to your irrigation or weather predictions so that you're not watering when it's going to be raining anyway. I think part of the fear-inducing part of this is that it's a really complicated system. And a farmer's data might be going to a lot of different people if they want to take advantage of it. So there are software providers, which aren't necessarily the same company that's providing the drone or the UAS. There are hardware providers, which might include the drone provider. It might include different sensors. It might include equipment that's attached to animals or actually farm equipment. And the data could be going to them. You might be hiring a consultant or an agronomist to help you with that. The data might be going to them. And so it feels a little out of control because a farmer's data could be going to a lot of different people. David showed a scan that a drone had done of a field, and that's what this is up on the left. How do you take that and make it into something actionable, as he said? Well, you can, once you have that data, you can program using software based on the colors you see how much you're going to apply of a fertilizer, for instance. And then you can store it on a USB drive and take it and plug it right into your tractor, and your tractor can drive up and down the road applying the fertilizer at the rate that you programmed in there. This can also be done wirelessly, and a lot of modern day farm equipment is ready for this. So it's pretty exciting in that way. So I know we've got some cattle folks today here and on the phone, and a couple ways that drones are being used with ranching include having smart ear tags on animals, or just RFID tags, or some way to track individual animals. The one that I've got on here is from a company called Herd Dog, and it's actually a Colorado company. And their device has been described as a Fitbit for cows, which I just absolutely love. It's got all kinds of biometric data about the cow, not just identifying an individual animal, but all kinds of information about its health as well. Also, with thermal imaging, which is one of the types of sensors that a drone can carry, you can find where are cattle or where are cows on your property. The image I have up here is actually of deer, but it would be the same thing if it were your cows. You could use a drone to find them. I think another part of why some of this feels scary to farmers is that there's a lot of people that talk about farm data as just a category. And it really is a lot of different types of data. And I think if we divide it up into different types, each one may be dealt with in a way that's different from the others and maybe make it a little bit less scary. So I think of it as 4 different categories. One of them is the owners or the growers' knowledge of the land, just which goes from farming it or having their cattle on it for year after year. Second one is their historical records. You know, what happened, how much seed did I apply, how much of inputs did I apply, and what were the results. That's all in their computer or in their paper records of their farm. Third one is the information you get from sensors like drones. Or there's also farm equipment that has sensors on it. And the fourth is the grower or landowner's personal information, their bank accounts, their name, their email address, all kinds of personal information about them. And because these types of data are so different, just glomming them all into farm data can make some things that sound more scary than they really are. And it's obviously, I would feel differently about my credit card information or my bank account information being shared versus maybe, you know, what seed did I plant in section 3. People have different beliefs, but it's not necessarily all the same. So infrastructure, I think Dave covered really well, you know, what some of the uses are. I do have one video because if you haven't seen a lot of drone footage, I wanted you to see how detailed of an image a drone can get when you picture somebody like climbing up a utility pole or being raised up in a crane or something. You can compare what this drone can do and see why it's just a huge safety benefit. So we're going to get this going. Here we go. Forgive the cheesy music. One drone provider who I know tell me that they've actually been hired by telephone company providers to fly a drone up their towers because people sneak up at night and put transmitters up there, but the drone could like fly up the tower and see the transmitters that weren't authorized and let them know. So you could really see if something's broken, if it's disconnected. Using some of those other sensors that Dave was talking about, you could see arcing, you know, it's all really great. He also talked quite a bit about mining, so I'm not going to go into all these different uses, but, you know, this is an example of one of the images that could be created using the type of technology he was talking about to help assess volume of pits and that sort of thing. We're going to talk about intellectual property, privacy, how licensing can help resolve some of these fears, the regulations, and some state and federal drone-specific laws. And I just wanted to raise as a starting point, and it kind of relates to this frozen category of fear, is sharing your data a problem or an opportunity? You know, this has been a common theme over the years with the internet, with music, with all kinds of things, social media, where there's a lot of fear about sharing your data, and then it turns out if you just do it without worrying too much, it's wonderful. Like, if we think about right now, everybody who has their website out on the internet, most of them get indexed by Google every few days. And if each person who had a website out there had to negotiate their own agreement with Google, about Google doing that, and with the cost and the time involved with that would just mean that we don't have the internet that we have now. There could be great benefits for people, both in terms of research and benchmarking, if they would maybe think about those different categories of data and consider whether it's worth being so protective of it. And obviously, every business has to make that decision for themselves. But both the value of having a larger data set, big data is the big term these days. There's a lot of value in that. And then the not needing to negotiate every license individually can both be big benefits of maybe being a little less restrictive with your data sharing. So we're going to start with intellectual property. We're not going to be talking on this section about the black box, which is the grower's personal information. That's the privacy law. And I think some of the fear about intellectual property, who owns my data, comes down to people thinking it's their personal data. And that's not really what we're talking about. We're talking about the other three categories of data: their knowledge, their historical reports, and what could be gathered by drones. So, when I was first asked this question a few years ago about drones, and farmers were claiming, we own all the data that comes off of our land, I was thinking back to very fundamental intellectual property principles and the types of intellectual property that are out there. Patent, copyright, trademark, and trade secret are the main ones. Patents, copyright, and trademark don't cover things, data collected by drones. But trade secret was a possibility. So I, did the analysis. I've got the definition of trade secrets from the Defend Trade Secrets Act up here, which means it has to be information that has independent economic value from not being generally known to and not being readily ascertainable to people, and the owner has taken reasonable measures to keep such information secret. Those are the three key things to be a trade secret. So I think if you think about a grower's knowledge about their land, that probably fits those as long as they've kept it secret. If you think about their historical records, that probably does too, as long as they've kept it secret, or they've only disclosed it under non-disclosure agreements or whatever. But the drone part doesn't really fit that. I mean, it's on open land that's viewable from the national airspace. It probably does not fit being a trade secret. And so I guess one of the things that might help with licensing is to think about the different categories and also explain to farmers and growers that we're not talking about all that. We're just talking about one category of it that may not be protectable under that. So then, okay, if trade secret doesn't protect data collected by drones, what else might? Could their real property rights in the property somehow protect the data that comes from the land? So I looked at, how far does your ownership go up into space? This is a hotly contested issue right now. The FAA, as Thad said, claims that they govern everything from hell to heaven, right? Some courts have used a 500-foot mark. Cosby, the Supreme Court case that Thad mentioned, said the landowner owns at least as much space above the ground as he can occupy or use. So maybe there's a claim that could be made that you own some data based on your land ownership, but it's not a slam dunk for sure. And then I looked at trespass and nuisance, other things that are related to entering someone's land or causing a problem on someone's land. And although both of those you could potentially get damages if someone trespasses or causes a nuisance, in none of those is the result that you own what the person filmed on your property or whatever. That's not one of the remedies that a court would give you. And practically, you could look on from an adjacent parcel and probably not do a trespass or cause a nuisance with a very quiet drone. Or you could fly very high where you would be difficult to detect. So I don't think these would really get to protecting intellectual property and the data that a drone collects either. Okay, so you've got a lot of uncertainty, no clear protection for that one category of data, which is information collected by drones. So what do you do? Well, agreements. I mean, we lawyers, this is perfect for us, right? We can draft agreements that very clearly specify what information is being collected, who owns it or who's got a license to it, and what can they do with it. The difficulty is because of that complex ecosystem with software providers, agronomists, people who might be hired by a mine or a infrastructure to fly a drone for them. There's a lot of parties that are involved with that, so you need to be careful with all of those agreements that if you're really wanting to retain ownership, that it's all staying with you. To try to deal with that negotiating independent contracts issue and how much cost and time that takes, the agriculture industry has tried a few different things. One is they have this Ag Data Transparency Evaluator that the American Farm Bureau Federation funded, where they kind of look at different apps and give them ratings on how transparent they are with what happens with farm data. The problem is it hasn't really taken off, so there's very few companies that have gone through the evaluation, but it has potential. Another one is standards. And with other technologies, this has been a huge help. To the extent we can come up with standards or everybody agrees, that reduces that amount of time and cost of negotiating. So there are some groups that have tried to put out standards. I can't say that any of them are necessarily fully adopted. Sometimes we get standards by default, such as I was talking about with Google, where there's a huge company that everyone wants to work with, and so whatever they say the standard is, we all sort of fall into line. Here we've got Monsanto has a platform that is starting to allow third parties to develop software to work with it, so that could be a potential. Or John Deere acquired a company a couple years ago that allowed them to connect their equipment to the Climate Corp, which is the Monsanto platform too. So we could end up with sort of a standard by default. Lastly, some people have suggested that we should have data repositories where every farmer or grower could put their data in a third-party repository, and then if anyone wanted to use it, they would be able to give permission each time for what would be shared and what wouldn't. It sounds really protective and safe, but it also causes a lot of negotiation costs. And it doesn't seem too workable in terms of actually, getting the business going. So, one of the key things about intellectual property is who's going to be the one to set those standards. And obviously all of us participating in that will help it turn out the way we want it to. Now we're going to move on to privacy. And we're going to talk about the legal and regulatory framework that's in place already absent drones or UAS, the barriers to understanding it, which I think also contributes to that fear, and the difficult due diligence that you would need to do if you really want to understand all the data, where it's flowing, and you might need to do that to draft privacy policies, which are currently a best practice for flying drones, especially if you're going to be potentially collecting information from other people, especially their photos or videos of them. We'll talk more about it. So now, as we think about those different types of data, we're not talking about somebody's knowledge about the land or their historical records. We're just talking about the information collected by drones and their personal information, so their name, their address, their email address, their device identifier. We'll kind of go through all the different categories in a minute. For those who aren't privacy lawyers, just to give you a little background on the U.S., which is very different from most other countries, we do not have a federal privacy law. We have specific privacy laws in certain areas, so financial privacy, health privacy, I'm sure you've all heard of HIPAA. There's children's privacy, there's privacy related to information about applying for a job, but we don't have one thing that just covers all of us. Some states have laws, most do, that you have a reasonable expectation of privacy, and there are different torts that come along with violating that reasonable expectation. We'll talk about what that looks like in the drone context. Kind of the closest we have to a federal law is the regulations and authority of the Federal Trade Commission. And they use their ability to deal with deceptive and unfair acts to enforce privacy regulations. One of the interesting things that's happened with the FTC in recent years is they've expanded thinking about privacy so that it's not just about an individual person, but it's also their device. They know that if you know the device identifier of my phone, and it's tracking me all over the place where I walk around, where I go into a store, which apps I download, that you pretty much know a lot about me. So if you're tracking a device, it's now treated the same as tracking a person. And you've all seen privacy policies when you've used websites or mobile apps, and that all comes from this authority. And the idea behind privacy policies is that you give notice to people of what you're doing, and you get their consent for what you're doing. And the things that you typically cover in a privacy policy is what personal information is being collected, what are you doing with it, and who are you sharing it with? And those are the same things you're going to see in some of these drone-specific best practices being imported into the drone world. So some people thought the FAA should be putting privacy regulations in their Modernization or Reauthorization Act. In fact, the Senate did pass privacy regulations for drones in April of last year, but before the final bill got passed in July, most of those were taken out. But just to give you a sense of what they were thinking about and what the Senate passed, they passed that commercial drone operators have to disclose if they're collecting personal information about an individual, so that kind of notice, and especially if they're using facial recognition. They had to disclose how they're using it, so if they're using it for advertising or marketing, kind of like behavioral advertising on the internet, that would be something they would have to disclose, and they'd have to disclose how long they were going to retain it and under what circumstances the information would be destroyed. So that was all taken out of the final bill and did not pass. But it did have one privacy-related provision, which was that the FAA would convene industry to develop standards for remotely identifying operators and owners. And obviously, if a drone is causing some problem on your land and you can't identify the owner, one way that you can deal with that is to shoot it down. Now, I would not recommend doing that, but if there's no way to remotely identify it, to be able to have your software say, oh, that's that drone that's flying there, and I gave it permission to do that, so I'm not worried about it. But that one over there, who knows who that is? If you can't remotely do it, then you're kind of stuck in trying to figure out who might be doing this on your property. And we've had clients that are having problems with drones entering their business property that they don't know who's flying them and for what purpose. So they did convene a committee in March of this year, and we'll see what that committee does. But it's interesting in light of what Thad was talking about with the tail numbers being removed as a requirement. So how we're going to identify drones, I think, is an open issue. So going back to my fear spectrum, we have other laws that are have been proposed. None of these three have passed, but just want to give you a sense for what's out there right now. The first one is the Drone Aircraft Privacy and Transparency Act, introduced by Senator Markey. He's introduced one before, which is very similar, so this is kind of like a redo. And under his law, the FAA would collect a data collection statement from everybody who is applying for a license or one of the waivers in order to operate a drone. And it sounds a lot like a privacy policy, but it's more intense than the typical U.S. privacy policy. It kind of sounds more like a European privacy policy in the types of information you'd have to tell the FAA. And then if you were a law enforcement or a contractor for law enforcement, you'd have to file a data minimization statement, which talks about how you're going to minimize what information you're collecting and how you're going to destroy it once you've used it. If you violate this, you fly without submitting those things to the FAA, then the FTC can take action against you, the state attorneys general can take action against you. There's a private right of action, and the penalties are $1,000 per violation or your damages, whichever is greater. That is not passed, but it's pending right now. The next one is just introduced last month, the Drone Federalism Act. This is a bipartisan proposal in the Senate, and it would allow state, local, and tribal government authorities to issue restrictions on the time, manner, and place of drone operations within 200 feet of the ground or 200 feet of a structure. Now, some people have pointed out that in urban areas, 200 feet of a structure is basically everywhere. So I think, based on what Thad was saying and based on the FAA's view of its authority, this probably is directly opposite of that. But I understand that some of the senators involved with this were buzzed by drones right up to their faces, per Robert's question. So they may feel it very personally, want to have local governments be able to deal with what's happening on the local level. The problem is, for people who want to operate drones in a large commercial fashion, this would be a complete nightmare. You'd have every city, every state could have different rules, every tribe, and to even figure that all out would be extremely time-consuming. The Trump administration has drafted some legislation that's going to be part of the National Defense Authorization Act, where it's about government destroying drones that pose a threat to safety and security. And they say they're going to respect privacy and civil liberties, but I don't have the details about that yet. But I assume we'll hear more about that in the coming days. Now, almost every state has either considered or passed drone legislation. So I just wanted to give you one example, but it's by no means the same as everywhere. This is a recent act passed by Indiana in May of this year. And what they did was they created 4 new offenses: a sex offender UAV offense, public safety remote aerial interference, where if you were using a drone to interfere with a first responder, you would be guilty of that. Remote aerial voyeurism, which is like a peeping Tom sort of statute, and remote aerial harassment, which deals with using drones to harass people where they might have a protective order against you or something like that. All of these are misdemeanors unless you have a prior conviction for one of them, then it becomes a felony. Or for the remote aerial voyeurism, if you publish the photos or videos you took of a person or you put it online, it becomes a felony. Litigation. There hasn't been too much yet. The EPIC right away filed action against the FAA. EPIC is Electronic Privacy Information Center. When the FAA came out with their rules and they didn't include privacy, they filed an action saying they should have included privacy. Thad already talked about Boggs' case where they shot down the drone with a shotgun. I've got some more details about it here, but since he already covered it, we're just going to skip ahead. Here's 3 more cases which deal with drones, but none of them are binding. It's just comments and dicta, so we're also going to skip quickly through these, but you can read them at your leisure. So what is your reasonable expectation of privacy, which is a key component of your rights under many different state laws? One way we can think about that is looking at the 4th Amendment and how the courts have used search and seizure. Some of these cases are going to seem really familiar from law school or later. They talk about land being open, and as long as it's open to view, it won't trigger 4th Amendment protection. So Dow Chemical versus the U.S., there was a photographer flying in an airplane. He photographed a facility from different levels of elevation, and they said that that was a constitutional search because it was searching an open area around the facility, which is more like an open field and less like the curtilage of a home. So if you don't remember from law school, the curtilage of a home is the area right around your house. So maybe your porch extends a little ways out where you would have an expectation of privacy. And when it's a facility, they said, no, that's not like a curtilage of a home. The next one, a lot of these are marijuana cases. The next one, they filmed from a fenced-in backyard. And they said, nope, that's fine too. They don't have a reasonable expectation of privacy in things that can be seen from a location where the public has the right to be, which in this case was the airspace over the home. The next one, another marijuana case, looking through the sides and roof of a greenhouse left partially open. That was okay. Constitutional. Last one, thermal imaging from outside a home. That was where the court drew the line. It said, nope, this device is not in general public use. The details of the home were previously unknowable, and so by taking that thermal imaging right up to the house, you violated the Constitution. I think this is very relevant for drones, especially as they have thermal sensors that they can hold. When we talk about privacy, what kind of information is included? I've got some very wordy looking slides here, which you don't have to read, but I did highlight in blue the types of information that a drone, that might be involved with drone flight, that would be considered personal information. This is from an FTC settlement over an app from 2013. I'm going to skip because I have a better slide a couple forward. This is from the California Attorney General report. You'll see very similar types of information. Here's where I pulled the key ones for drones. So the types of farm data that could be considered personal information would be the grower and owner contact information, the geolocation of a person or their device. You can see if you're filming or taking pictures, this is going to be an issue. Image or video of a person, device identifiers, as I mentioned, credit card information, financial information, if you're hiring somebody to do this for you. Infrastructure and mining would be very similar if you're hiring somebody, but if you're doing it yourself, then it's probably the geolocation of the person or their device and an image or video of a person. And we'll talk in a few minutes about some technological solutions to these things, because we don't only have the law to rely on. There are technologies being developed to help not collect images of people when you don't want to help your drones fly in corridors where they're less likely to encounter people, and technologies to take images of people out of your footage so that you don't store it, and it reduces your compliance responsibilities. This is about the due diligence, and I've already talked about how complicated this ecosystem is, but if you're thinking about writing a privacy policy and talking about who you're going to share the information with, you'd have to kind of go through, okay, the software provider's getting it, and the agronomist is getting it, and or your, the vendor that is flying it for your mine, and you'd have to be able to describe all of that in a privacy policy. So what do you do with all this uncertainty where the laws are like conflicting with each other, and we don't know? You can change the law, which we'll talk about. You can pass a new law. You can self-regulate, which is probably the key right now, and you can have really great agreements. And lastly, hopefully not have disputes. I'm just going to hit a few highlights. As I mentioned, a lot of states have passed drone-related laws or are thinking about it. Some of the common themes are that you have to identify the drone owner or operator on the device. This is obviously less desirable than being able to identify the drone remotely, but at least it would be on the device if one crashed. Hopefully you could see it. You have to register with the state, which Thad may or may not think is preempted by the FAA. Some of them prohibit municipalities from regulating drones, whereas this new federal act is actually enabling municipalities to regulate drones. So you can see we've got a conflict there. Some states say the tenants need written permission from the landowner to use a UAS on the property. That could be pretty key for growers if you're renting land, to know that, if that's one of your states, or if you're renting to someone. Louisiana actually passed a law that said farm data collected through a UAS belongs to the legal owner of the property where it's collected. So if you're working in Louisiana, that would be a good one to know about and make sure your agreements are really clear. Texas had somebody filming, I think it was some feedlot or slaughterhouse where people were dumping blood into a river that they shouldn't have been doing. And so there was a lot of lobbying, and they came out with a very interesting law that said it's a misdemeanor to capture, display, or distribute an image of an individual or privately owned real property. So I'm thinking about my vacation pictures and a little worried about that. It's very broad. I don't know that would hold up, but that's what the current law is in Texas. Utah just passed one that says it's a misdemeanor to chase, disturb, or harm livestock through UAS use. If you're bored on a Friday night, I recommend looking at YouTube because everyone's filming herding their cattle with their drones. And because they're filming the cattle, you can see some pretty exciting cow reactions to drones, let's just say that. Another common thing is to not use drones over critical infrastructure facilities. I think Thad talked about that. I'm going to skip this self-regulation. If you're really interested in farming self-regulation, I recommend looking at these things. But the key one for everybody to know about, because it's for all industries, is these best practices that were put out by the NTIA. And they were released in May of last year and updated in June when the FAA new regulations came out. And there's 5 of them. I'm really going to just talk about 2. And very briefly, there's a lot of text here that you could read on your own. And if it's going to sound familiar when I was talking about privacy policies. Inform others of your use of UAS. So you're supposed to try to give prior notice to people of when you're going to be flying a UAS, especially if you might be taking pictures of people. You're supposed to put out a privacy policy that covers what information is being collected, what you're doing with it, and who you're sharing it with. You're supposed to, if you're following the best practices, show care in your whole design. You might have heard of privacy by design. It's like, think about, can you avoid collecting it in the first place if it's not essential for you? Can you avoid storing it, as I was talking about with people's images? So under the best practice, you're supposed to avoid using UAS to intentionally collect covered data, which you could consider personal information, where the data subject has a reasonable expectation of privacy. Common themes we've been talking about. One of the key things they called out was try to avoid using UAS for the purpose of persistent and continuous collection. I think the biggest application of this is if you're using drones for security monitoring, and you're going to be flying by somebody's house 20 times a day or all the time, the same property, this would be something to think carefully about, and what kind of notice you need to give to that family or whoever might be commonly on your footage. Also, you're supposed to try not to fly over private property. This is going to be an interesting one for everything we've been talking about. And to establish a process for receiving privacy concerns if somebody doesn't like what you're doing with their personal information. Limit the use and sharing. I'll let you read this one on your own. If you work in privacy, it sounds very similar to other things you've seen in other contexts. Use some good security once you have that information, and monitor these evolving laws, because obviously a lot of this is in flux. Here's who supported it. You'll see some big names that are both on the technology and privacy side. So just to wrap up, thinking about those best practices, thinking about the regulations and laws they stand now, here's some ways to reduce your risk. Fly over your own land or your own right-of-way rather than somebody else's land. Think about these technological solutions. If you read this paper I have linked here, you'll see it's really amazing what people are developing right now, and this may really be the answer. Like, I could foresee a future where you could, on a computer, designate your home as a no-fly zone for drones, where they just wouldn't be able to operate in your curtilage of your home. That would be nice. There's always bad actors, but to the extent people are trying to follow the law, some technology will make it easier for them to do that. Provide notice if you know you're going to be flying in a place and you know there are going to be people somewhere nearby. Try to give them notice. Create a privacy policy. use special care if you're releasing any of this information to the public. You do have some additional responsibilities to try to get out images of people. And if you're using it, drones for persistent and continuous use, that's probably your highest risk. So you might think about designing that really carefully. I'm just going to let this, because I think I am now out of time, I'll let you read these on your own. Hopefully you feel like you have a better sense of understanding the types of information that drones collect and how we might deal with them in licensing and insurance policies and all the ways that we lawyers are going to be helping our clients maximize their benefit of using UAS. Thank you very much.
Thank you, Jamie. We're going to take a 10-minute break before our last session. And again, if you haven't filled out the forms for CLE credit, if you need it, please fill out the form. We'll meet back here at 11 o'clock Mountain Time. Welcome back, and this is our third session today, which is a business panel discussion featuring Aaron Leitzig of Pulse Aerospace and Eileen Lockhart of Xcel Energy. I'm going to separately introduce each one of them. Eileen Lockhart leads Xcel Energy's Unmanned Aircraft Systems program, including the multidisciplinary UAS team and a business-focused UAS operations, so actual use of UASs. Xcel Energy was one of the first utilities to obtain FAA approval to fly UAS missions. The company's UAS team has successfully executed more than 14 diverse outdoor concept missions, spanning its electric transmission, distribution, high-pressure natural gas transmission, distribution, and generation operations. These missions demonstrated the technology can successfully improve safety and productivity in a variety of practical applications. Eileen also represents Xcel Energy on EEI Unmanned Aircraft Systems and IEEE UAS teams and is involved in EPRI's UAS Tailored Collaboration Project. So Eileen, if you would please give us an overview of Xcel's drone program.
Thank you very much. So thanks for having me here today. It's a pleasure to be here. Xcel Energy, you know, we recognize that drone or UAS technology is going to be transformational, and so what we've been doing for the past couple of years is really taking a look at our service territory here and trying to figure out, with this new change of technology, how can we embrace this new opportunity, given that our territory is very diverse. We have multiple different climates, multiple different altitudes that we span across, and we just have a lot of transmission lines out in the middle part of the United States. So, you know, with this diverse territory comes lots of different weather challenges, tornadoes, you know, mountains, you name it. So, just a little bit about the company. So, we started looking at UAS technology back in 2013. We experimented with quadcopters indoors inside of our plants, and really how that started was, you know, we would have a bunch of engineers that would have to climb scaffolding that could be 10 stories tall to inspect boilers or various specific pieces of equipment inside our plants, and it was very dangerous and very costly. So in 2013, that's when sort of the commercial market was penetrated around drones, and we bought a couple quadcopters and started experimenting. Well, could we use a flying camera, essentially, and inspect these pieces of equipment? It took some time. We crashed a lot of quads. You know, we had a lot of lessons learned, but at the end of the day, we quickly figured out that that was a really good use case for this type of technology. And today, we've actually been able to save hundreds of thousands of dollars using quads or small drones indoors to do inspection. That case has actually expanded, and now we're looking at roof rafters, inside stacks, very specialized, hard-to-get-to areas, confined spaces, and it's a really promising market for us. So that's sort of how we started in the UAV business. In 2014, we decided, well, due to the success of our experiments indoors, let's try to figure out how to use it outdoors. And at that time, the market was changing. There was legislation that was put into place. You started hearing about it in the news a little bit, and so Xcel Energy, alongside with other utilities, really wanted to understand what is going to be the business impact to us and how do we embrace that. So we started a small team, 2014, didn't know anything about drones or UAVs, and really just kind of put our heads down and started researching. It was apparent really quick that this is going to actually change not only how we perform and maintain our infrastructure, but how we actually do particular processes and procedures, and how our workforce is going to interact with this type of technology. So it was kind of a big eye-opener back in 2014. At that point, the small team decided, okay, well, instead of looking at specific use cases, we need to kind of broaden our view and look at this from a holistic point of view across all of our operations, because it just, it blew up from that point. So we started doing lobbying. We partnered with EEI. We started talking to other agencies, trying to figure out, where are we from a legislative point of view, gather different stakeholders' opinions. And we decided, that we wanted to become a commercial operator and really kind of understand how we could use this safely, not only from an internal perspective, meaning putting these tools in our employees' hands, but also from a contracting perspective. We wanted to understand how we could do that safely. So in 2015, we applied for a Section 333 exemption, or COA. Now, what was interesting about that time is, at that time there wasn't very many exemptions or COAs that were granted, particularly around utility infrastructure. And so we were one of the first, as you mentioned, but we did it in partnership and in collaboration with other utilities and other agencies. So it was really sort of a joint process that we went through to kind of figure out how do we become a commercial operator, because that is outside of our normal business scope. Just that exemption process and that application process was a huge learning curve for us. Nobody in our legal team had any idea on how to apply for something like this. We didn't have the internal expertise. And so it really, it was a very interesting dynamic of really pulling a team of experts together to help us understand how do we do this. May of 2015, we received our exemption and our approval to basically fly a specific aircraft in very isolated cases across our system. So at that time, we purchased an octocopter, and we experimented using that platform on various different early proof of concept missions. So as soon as we got our exemption and our COA, we really tried to get into the weeds in terms of mission planning and developing that type of flight profile. So once we got our hands dirty, we defined at that time various different ways to use these types of aircraft: visual line of sight operations, beyond visual line of sight operations, and proof of concept. So back in 2015, we were at the proof of concept stage. We just wanted to lift the drone off the air safely and not hurt anybody. That was our mission. Around that purpose, we executed about 3 different missions, just lifting it off the ground and landing it, trying to figure out what the controls were. And from there, we expanded across operations. Then we also we developed various missions based on visual line of sight scope or beyond visual line of sight scope. And so there's a clear differentiation between those types of usages around UAS. We think that at Xcel there's definitely a massive business case for both of those types of opportunities, both visual and beyond. All of this work that we did, all this R&D we did in 2015 was to get to a future vision of establishing a dedicated resource or a program office that would govern UAS operations for Xcel Energy. We knew this was going to be exciting, cool, fun for the employees, and we wanted to put some structure and framework, policies and procedures in place internally. and decided to, our goal to create an office, if you will, that would house all of the activities. So just going back to some of our proof of concepts that we completed, from the span of August 2015 through February 16, we completed over 8 proof of concept diverse missions. Everything from data collection of substations, transmission line inspections, wind turbine blade inspections, indoor equipment inspections, distribution and transmission gas pipeline inspections. We really sort of wanted to get our feet wet across the board. Each one of these missions build upon themselves. So, for example, our first outdoor mission that we ever did was in the substation environment. Energized subs, the scope was we needed to get nameplate data from energized pieces of equipment. And it was for a NERC requirement. This isn't something that happens necessarily on an annual basis. It was kind of a one-time thing where we just had to validate nameplate rating and facility rating data. And generally how you do that is you either have to de-energize the sub, or you have to bring in a bucket truck with a gentleman or a person holding a hot stick and try to look over and view what the nameplate data is and capture that on a pad or by a camera. So instead we decided, well, we'll fly that octocopter, as you see, instead, and see if we can just zoom in from 100 feet, 200 feet, whatever the specification was. And in fact, it proved to be a very promising and successful mission because we were able to do that across 5 different energized subs within, I think it was about 3 or 4 days. So it really kind of, it taught us that we could get much more efficient with this process and we could do this much quicker versus traditional methods. So it was a really good first proof of concept. From there, we spanned on to transmission line inspections. And here, we view this particular mission as, beyond line of sight. Eventually, where we want to go is we want to be able to inspect our transmission lines out of the line of sight with potentially maybe an unmanned aerial aircraft or some other means of technology. So we started that process, and in fact, I think we used your Vapor 55 in that particular one to perform these inspections. It was the first one was in North Dakota on a line that had been recently burnt down by fire. So we just wanted to kind of get a health assessment of that line, and we learned a lot through that whole process. And at that time, technology was really new, it was emerging. We didn't have the latest, greatest thing, but once again, we learned that we could do this, in fact, with an unmanned aircraft long term. We also looked at volumetric surveys and various different surveys across our energy supply system. So we have lots of different ash piles and coal piles throughout our plants. And so, one use case that came up was, well, instead of deploying a helicopter that's equipped with LiDAR that could take anywhere from a couple hours to a full day, depending on schedule and time and budget, and let's try to fly a drone, right? Let's see if we can use an unmanned aircraft to do that. And so we were able to perform the same exact function that we do today with a manned helicopter with an unmanned aircraft in 8 minutes. So this was a huge efficiency save from our perspective because we have guys on the ground operating a small aircraft who get the job done in 8 minutes versus, again, deploying a manned helicopter fully equipped with LiDAR, has 2 people in it plus observers on the ground. So it was a game changer, if you will, for us. At this point in time, in 2015 into 2016, the technology was becoming more visible. Our company was starting to see the benefit, our employees were starting to see the benefit, and from the industry side, it was getting more and more exposure. So a lot of momentum was building at this time. We decided to basically do the same thing on our wind turbines. Xcel Energy is the #1 wind turbine provider here in the United States for 13 years, and so we've got a lot of infrastructure and a lot of wind turbines across our system, and not a very good way to really inspect the blades or the health of the blades. Traditionally, how it's done is you have to have somebody basically climb up the turbine and propel down and take a look at, is there delamination on the blade? Or you have to have somebody on the ground using spotting scopes to see what the health assessment is. Here we decided, well, why not try to fly a camera and see if we can get the same type of effect or same kind of assessment. So we actually did that with our quadcopter, and it was very successful. In the future, what we would like to do is maybe fly an unmanned aerial system while our blades are still active and running, generating electricity, and inspect the health. Whether it's at a higher or lower altitude is to be determined, but that's where we see this going. On our gas side of the house, we wanted to see, well, today we fly helicopters for leak detection, and we have to check our gas pipelines every year for leaks. So can we do it with a drone? So on this particular use case, we isolated it to a section of pipe that was exposed, and we put a gas sniffer on it. And again, this was, can I get it off the ground and can I smell gas? We simulated a leak, and it turned out that, in fact, we could detect that leak at that time. This was transformational because there wasn't anything on the market that was available from a commercial perspective for gas leak detection for UAVs. So we were very excited to see that this is a promising technology. And then finally, from there, that basically led us to being able to perform the first beyond visual line of sight flight in February 3rd of 2016 over our transmission lines. So while all of this is happening, we're working with the FAA, we're socializing what we're doing, we're trying to understand the regulatory environment, which is evolving and changing. And in this case, we were able to get essentially a one-time approval, if you will, to fly beyond line of sight using Paul's system. It was a 22-mile span of transmission lines, and again, it was basically defect detection health assessment. It was in a very remote area in Texas, and so really the scope was, can we go, how do we get from the visual observer dynamic to beyond visual observer, and we were able to do that. Very exciting times for us. So now what are we doing? Well, if you fast forward to today, basically because of all of our proof of concept missions and our R&D that we did back in 15 and 16, we established a program office. The company believes and sees the value of this technology and wants to form some structure around it. So we established a program office, and we decided to partner with the state of North Dakota and local and state law enforcement to figure out, how do we use drones from an emergency response perspective? A disaster happens, what do we do? Can we become more efficient? The biggest problem that we have in emergency response, or storm response I should say, is that we can't get to our damaged assets fast enough or very quickly after a storm. So it could be a couple days before our employees are physically able to access our assets and come up with a solution, or at least a health assessment on what's wrong. So, why not fly a drone, right? So we partnered with the state of North Dakota and applied for a research grant to study this business case, or this use case. It's a year-long grant, and we're almost through that year. So we have performed, basically the scope of this was, do we use a high-altitude military aircraft to assess damage, or do we use a low-altitude visual line of sight aircraft to assess damage? Which is better from a large-scale type of perspective? And so we're testing both, and we are going to basically come out with a white paper report after this research is done. And we'll share it with EEI and some of other partners on the results. Very exciting, very dynamic partnership here with North Dakota, and it's definitely evolving. So more to come on that. Again, as we're kind of going through all of these proof of concept missions, there's a lot of parallel paths that are happening. from an industry perspective. On the business side, what's the business case? On the national side, what's the regulatory protocol, right? So we as a company and as a program have to sort of figure out each one of these parallel paths and the timing of when it's all going to work out for us. We believe that we'll be able to really integrate and use drones within our operations very, very soon. The FAA has released Part 107 for visual line of sight. They've enabled commercial users a pathway to be able to really embrace this technology. And so we really believe that this is going to be something that's going to be real world and our new reality in the very short term, meaning probably in the next year or two. So that's it. Thank you.
All right. Thank you, Eileen. So just so everybody knows, we're going to go through both speakers and then have a chance for questions after they both too. And next I'm going to introduce Aaron Lessig, who is the CEO and chairman of Pulse Aerospace. Pulse is the premier developer of helicopter unmanned aircraft systems technology in the United States. Pulse Helium technology brings dynamics, control, payload, and endurance capabilities historically limited to high-cost military vehicles to commercially relevant price points and systems. Pulse leadership has served military, commercial, university, and non-military UAS customers for nearly a decade. Pulse's technical advantages are recognized in both light and heavy payload applications using traditional helicopter designs that are more scalable than other vehicle configurations. And so Aaron, as a developer of Pulse Unmanned Aircraft Systems, please give us an overview of what Pulse is doing.
All right, well, I appreciate everybody taking the time to allow us to present. And really I want to take a moment to talk a little bit about the market and what we're seeing in general and happening before I get into the specifics of Pulse. I think if everybody thinks back to the .com boom, where anybody that had a website or was a .com was a technology company, and we're seeing the same thing happen in the UAV market. So there's very much a kind of silicone froth around UAVs, UAS, drones, etc. Some of which is justified, some of which is not. And I think from a technology perspective, UAS is not a strategy. It is a tool to be used to solve understood and well-communicated business problems. So when we meet with organizations such as Excel, it's much easier for our organization to translate a business requirement into a technology solution if the customer understands what the problem is. And so we encourage folks that are looking at this space to really understand what it is that they're trying to accomplish, and then to allow us to help translate that. And generally speaking, that's what allows us to be the most successful with our customers. To kind of take a step back and talk a little bit about Pulse, we've been in the unmanned space for over 12 years. We come from an aerospace engineering perspective where we've worked with military customers, research and development customers, et cetera, over an extended period of time, whether it's helicopter, fixed wing, platforms, and really our focus has been around that control and optimization technology. So what that means is, how do you get a system to perform better to allow you to carry the payloads you need, to collect the data you need so you can carry on your business? And we branded this HeliSense. And so what HeliSense is it's an aerospace process that allows us to look at a vehicle, look at a problem set, and to create the system that performs best in that application. We're very much looking at it as a software technology provider that manifests itself in vehicles. I think everybody's talked about how big the market opportunity is. Quite frankly, what we've seen is early adoption has been on the multi-rotor side, so the DJIs, that space doing things like take pictures or do inspection, and that is the right application for those types of technologies. But what we're seeing is that as businesses understand more and more about what they're trying to do, they want additional capabilities, and that's really where Pulse comes into play, is when you get beyond a kind of pop-up, look at something, get down approach, we focus more on that. So once again, aerospace engineering firm, about 15 years of experience, focused on automation. We've really selected helicopters as the platform we use the most. The reason we've done that is we believe that from a payload capability perspective and an endurance perspective, it has benefits over both a fixed wing and a multi-rotor. So we can fly longer than a multi-rotor, and we can carry more weight than a fixed wing. So we feel that covers the biggest breadth of demand for the market. The reason you don't see a lot of helicopters and you see the multi-rotors is multi-rotors are a solution to a control problem. They're very easy to automate, but they have a penalty when you look at endurance and payload. So a helicopter, because it's hard to control and automate, that's where we come into play, and we can actually make those perform the way our customers want to see it. We worked with Department of Defense, Special Forces, Skunk Works, a lot of large commercial customers as well, mining, energy, oil and gas, etc. But all of that is born out of that aerospace-based platforms. We work with platforms anywhere from 30 pounds to 1,200 pounds, actually to multi-thousand-pound vehicles all over the world. Antarctica, Greenland, the Australian outback, Death Valley, and we say Kansas, which is where we're based. And it seems funny, but if you can't fly in hot weather, and you can't fly in cold weather, and you can't fly in wind, you can't fly in Kansas. So it's a interesting place to be an aerospace company. So getting into what makes us unique and kind of how we start to break out where we see the market and how it plays. We've built this very confusing diagram that I'm sure you guys all understand at first glance here. But what we see in the market is there's a lot of focus on data and analytics and autonomy. And what I mean by autonomy is, can you make a vehicle do something cool for a specific application? That is absolutely a great market strategy. The issue is when you look at the fundamental basis of kind of the aerospace market, whether it's payload integration, high capability payloads, full flight authority, control systems, and then aircraft design, you don't see differentiation. So you see, fixed wings fly the same amount of time, multi-rotors fly the same amount of time, the helicopters fly the same amount of time, and then they're trying to feather on additional capabilities, which is good. But Pulse is really focused on this lower piece of the pyramid here, where if you can enable a UAS to perform better and to do kind of more traditional work that you see in line with manned vehicles, then when you add autonomy, when you add data analytics, you can increase the value of that. So we choose to differentiate on the basis of aerospace capabilities and then bring in partners, et cetera, and these very niche data and analytics applications. So kind of going further into breaking that market out, in kind of the 1 hour, or excuse me, the 15, 20 minute flight, maybe up to an hour with a fixed wing endurance area and a couple pounds of payload, it's extremely congested. You've got pretty much every multi-rotor performs the best, and the market strategy there is you have to be able to manufacture more cheaply than DJI. You're not going to be able to do that. So, in my opinion, DJI has won that multi-rotor market hands down. On the fixed wing side, a lot of the mining applications, et cetera, that you see with fixed wings, they'll fly for an hour, which is certainly a benefit over 15 minutes on a quad rotor, but they can't carry payload. When you get into heavy payloads on a fixed wing, all of a sudden the vehicle gets very, very big. It's a 15, 20-foot wingspan type vehicle, and it becomes unyielding. And you also lose that vertical takeoff and landing. But what we see is these kind of hobby-grade systems trying to move up market into the commercial space. At the same time, you have military vehicles that are built around government contracting, so high cost, high operational footprints, extremely intensive in terms of a management process. They're now trying to move down market into kind of that commercial space. And where Pulse sits is squarely in the middle. So if you want to carry a lot of payload, if you want to be able to do interesting things from an autonomy perspective, and you want to be able to fly for a long time, that's where Pulse sits. We're not going to compete down here. We don't want to. And the very, very large multi-million dollar systems on the military side are not our focus currently as well. So some examples of work that we're doing, and really this talks about the breadth. So we can do a lot of different things, and that's part of our problem organizationally is if you have a lot of capability, how do you focus? And that gets really hard because it's interesting to do a lot of different things. But we are working with special forces on a regular basis. With Excel, we did do the first commercial gas leak detection, and we've expanded that effort with Worley Parsons in the U.S. and Australia. We did the first medical delivery beyond line of sight, so we flew as a 14-mile mission where we dropped 12 pounds of blood on the third-story rooftop of the building, flew back, did that 4 different times, had a flight variation of about 8 seconds. So that was an interesting demo. Oil detection in waterways and in the ocean. So how do you fly and look for oil and gas leaks on the surface of the water? Mining management in Australia, Asia, and South America. This is a market that is growing pretty rapidly. They have a lot of demand for very intensive, specific, high-quality data sets, very much like the utility markets. So this is something that we see as a big opportunity and we match well with. Beyond line of sight, utility work with Excel Energy and others for NERC-FERC LiDAR detection. Another application is tethered UAVs. So think of an extension cord up into the air, bringing fiber optic cable to the ground, replacing a cell tower, which I didn't think the market was going to be as big as it is, but we are working with AT&T and Verizon heavily in that for emergency responder or additional capability or capacity type applications. We do have Army and Navy airworthiness certificates, and another interesting application is we're looking for sharks in Australia and dropping buoys in the ocean if we see a distressed swimmer, which once again makes sense to somebody. So there we go. But in the end, we have 30 plus payload configurations today. We're a pickup truck. So if you want to put a sensor on it, that's fine. We can integrate that, and our controls capability allows us to adapt to multiple payloads versus being a one-trick pony. So from an economics perspective, more capability, more missions, better return, etc. This is a Vapor 55. This is one of our vehicles. We have both an electric and a gas version of this. It's about a 8-foot rotor diameter vehicle, so it's a large vehicle. The electric version will fly a full payload for a full hour, and then the gas variant will fly up to 8 hours. And then once again, lots of different applications in many different market segments. This is just a kind of technology demonstrator is the way we look at this, but this is being deployed all over the world as an interesting vehicle that we've kind of built our bread and butter around. But on the payloads, these are just a few example payloads. So kind of the low-end cameras all the way up to $200,000-$300,000 LiDAR systems. Interestingly enough, when you look at a workflow a lot of that comes back to similar payloads. So a utility company wanting to do NERC-FERC assessment is going to use a LiDAR a lot of times. A mine that's trying to get very, very detailed survey data about a pit or a face of that mine is going to probably use LiDAR as well. So we can handle that, but then on the back side of that, what does a company do with that data? So if you're getting more frequent data, if you're getting better data, does that allow you to then make better business decisions? So really the question there, and something that we pose to our customers a lot of times is, don't look at UAS as just a cost avoidance opportunity. There's more to it than that. If you can go collect more data, you can collect it more frequently, will that then begin to open up trends? Will that allow you to do analytics that you haven't been doing in the past, and therefore drive different business decisions and discoveries that perhaps you weren't seeing because the frequency of data collection was lower? So, from our perspective, we see that as being the big opportunity, which is more data, more often, better analytics, better business decisions, and then that just continues to circle through. So I got some pictures in here just because I think they're interesting. Hopefully you do too. On the left here, this is a gas leak detection system we have on a Vapor 55. On the right, this is a Vapor 55 that we're flying, which is replacing the manned helicopter in the back there looking for sharks. The top left is beginning of a beyond line of sight LiDAR inspection on utilities, and then you can see some of the data outputs on the right. The bottom right picture is about a 9 to 12 square kilometer ash dam in Australia that we flew. This is normally something they do with a manned vehicle, but we're able to do that in a single flight. Lead line pulling, and then this is a photo of the medical drop that we did with Special Forces and State Department. So same vehicle, a lot of different applications, and so it's understanding how you use that technology to drive value. So kind of in the end, when we look at our value, certainly beyond line of sight is one thing that we're very comfortable with, and we see a lot of future in that, but you don't have to wait for that. We suggest that companies get their feet wet with visual line of sight type applications, understand what the workflow is, understand what's valuable, understand, do you want to do this in-house, do you want to outsource it, learn easy, don't start with really hard things. In terms of payload, this is obviously an advantage we have, but we think it translates to our customers. Do you know what data you need? Do you know what payloads you need? How do you test that? How do you look at different applications and do it off of a single platform, so you streamline your training, you streamline your operational expenses. Flight automation, obviously, if the vehicle isn't stable, if it can't perform well in a lot of different conditions, it's not going to be safe, and you're not going to have a scalable approach to UAS. Adaptability, this is what we talk about a lot, which is we've kind of future-proofed our systems, and that as technology changes, we can adapt our vehicle through effectively a software patch or maybe a firmware patch to add additional capability, automation, etc. So you're not stuck with something early on in a technology cycle that could be expensive to get out of if you're not planning ahead of time. And then Internet of Things and big data integration. We are doing processing on board of our systems now. So as you look to the future, do you want to collect all the data that's out there and process through that, or do you want to look for specific triggers? Do you want to look for what's changed? Do you want to look for certain algorithm-based triggers, and just collect that and then process only what you need? So these are some of the areas that we're moving into. We'd love to work with our customers to understand what that need is and really take more of a technology partnership approach to something versus a transactional product approach. So, thank you very much.
All right, well, thank you very much. I'm going to start off with questions, and if you have questions in the audience, feel free to jump in. So first, Eileen, I'm going to start with you. You talked, with Thad was speaking earlier, he showed a photo of a quadcopter, I think, that ran into a utility line, crashed and burned, and wasn't one of yours, crashed and burned, and the person probably being charged with that because he was just a casual user, it looks like. But as far as your program goes, I mean, you're flying intentionally right next to utility lines and things like that. Do you have an internal training program or protocol that you work through, or how do you get your people safely operating?
Yep, so we currently are outsourcing the majority of our UAS operations right now, leaving it to the experts with our expertise in terms of how far away we want you to stay from the lines, things like that. But in parallel, we are developing our own internal program, but it's not done. It's still being worked, it's still being understood. So those kinds of criteria or best practices are being developed.
Okay.
Yep.
Questions from the audience anyone might have?
Mine's really a three-part question, but it all relates to how the external party that would rely on the information that is created by the device on the UAS, how receptive are they to that? And the three parts are auditors for the coal stockpile, the environmental regulators for the ash pile, and Hartford for the boiler inspection.
So if I understand your question right, so far when we've been going through these proof of concepts, our auditors have been very receptive to the data because it's a third party. So it's kind of it's a non-biased approach, and the pictures and the imagery that we provide them speak 1,000 words. So we have not yet run into an issue in terms of some sort of liability issue or faulty data at this point in time. However, I suspect in the future that's going to be something that's going to be escalated, and we'll have to come up with some sort of protocol on why we think this is bona fide data or why we're using this against some sort of case or audit. So,
I think from my perspective, the way I would answer that is I would say the expectation shouldn't be different on the data sets. If you have an expectation that it's survey grade, that it's of a certain quality, you shouldn't change that because you're using a UAV. And if the data set doesn't meet that requirement, then it shouldn't be accepted. And if you go into the business situation where you're saying, here's the requirement and you can define it, and the data that's provided meets that or exceeds it, then the adoption should be there. Of course, if it's not as good as what you're already getting, then you're going to run into adoption problems. So set the requirements in a very stringent manner would be my suggestion.
Other questions from the audience? So, Aaron, flashing forward 5 years, where do you see this industry 5 years from now?
So the question was, where do I see the industry in 5 years? I think from just a market presence perspective, I think you're already starting to see the market select the winners, and I think that's going to continue to happen. So you're going to see certainly a reduction in the number of technology providers in the market, and we are seeing that today. I think you're going to see regulation continue to advance to the point where kind of broader application for some types of UAS is going to be more widespread. I hope it's not for everybody. I mean, I think there should be stringent requirements around the technology itself. So I think that will become more prevalent. And then in terms of the data sets, we're seeing better and better sensors that are being miniaturized. So I think that will continue to happen. And so the data sets that are coming off of UAS will continue to get better. But at the same time, I do believe that the market is going to really understand where value is created and where it's not, and the froth will be off this thing. I mean, it will be, there will be certain areas where UAS is used, there will be certain areas where ground-based data collection will be used, and there will be other applications where manned collection is used, and I don't think that's really clear today.
Eileen, same question. Where do you see the industry in 5 years as it relates to XL and otherwise?
Yeah, I would agree with Aaron, what he said, and from a utility and maybe from a personnel perspective, I see a culture shift is going to occur from a workforce relations standpoint, from graduates in college. You know, we're seeing an uptick in a lot of new technology degree programs around unmanned aircraft systems or robotics. And so we as a company and other utilities here will have to figure out how do we retain these kinds of employees or these new way of thinking given the state of the industry. How do we manage it? What is the governance structure? I agree with you 100% that, you know, our goal is not to use unmanned vehicles in every part of our system, to have a very purposeful objective on when we use these tools, and so there will probably be some sort of best practice or brand created in the next 5 years that will help manage kind of the influx of this new technology in all the different markets out there. So I think it's booming now, and it's going to get to a spot where it's regulated appropriately, and then whatever shakes out will be really the leaders of the market. Yeah.
So, Aaron, a question about the technology. What technology barriers or impediments do you see need to be solved to increase compliance with either FAA rules or just commercial acceptance and use of the unmanned aircraft?
So the question was around what do I see helping adoption on the regulatory side and then on the commercial side from a technology perspective. And I think going back to the gentleman's question earlier on the commercial side, I think it's prove it. You know, what's going to drive adoption on the commercial side is prove that it's valuable. And if you're collecting high value data sets and you're doing it at a lower cost or with more frequency that creates granularity that you don't already have, that will help adoption. But part of that's on industry to pick the right questions to try and answer. On the regulatory side, I think it's similar. There's a process that the FAA is going through in testing different methodologies, which is the right way to do it. But I think it's also differentiating different types of technology from a regulatory perspective that then maps to those applications. So one technology should not be allowed to do maybe things that they're not capable of doing, and so that needs to be kind of sifted out, I think, on a regulatory perspective. So.
Other questions that anyone might have in the audience? I think just following up on one concept I have a question really about public acceptance of seeing unmanned aircraft or drones flying around. And I kind of gathered from both of you that you maybe fewer flying around, but better quality, more directed towards specific uses. But am I understanding that right? That's where you'd like to see the market go. I'll start with Eileen. Is that?
I mean, from a utility inspection and maintenance and security perspective, yes. I don't want it would. I wouldn't want you flying next to my lines, right?
Yeah.
So to have some sort of protection put in place for utilities and other infrastructure that is critical, I think is necessary and mandatory to make this work. But at the same time, with the market on the hobbyist side, I mean, there are millions of these things out there already. There's almost 1 million registered pilots. So it's going to be how do you balance that, the hobbyist section versus the commercial market.
Yeah.
So.
Aaron, anything?
Yeah, I would answer. I agree with what you're saying. I think the expectation shouldn't be that there aren't going to be accidents.
Yeah.
Because there are.
There
there absolutely will be. So how do you minimize the impact of that? I mean, we had a military vehicle that landed in Evergreen after flying on its own for a day or whatnot. You didn't hear a lot about that, but if you have a small system that lands in somebody's yard, then it's an uproar, which I certainly understand. But I think there's going to be a process of understanding kind of the sensitivity around that will go down, I believe. But accidents will happen, and I think that's going to be on the manufacturers and OEM to be able to answer for that.
I'd like to add, from a state perspective, I think it's going to be up to the various different states on what the local law enforcement and legislation is going to be that will really kind of help drive the culture change from a public perspective in terms of, are you invading my privacy, or are you doing something good for us, or what is your purpose of using this drone, and why are you here? I think a lot of the various state and federal regulation will help with that change.
Yeah.
So.
And I'm assuming you'd both like to see more federal regulation that applies across the board rather than piecemeal state-by-state regulation or city regulation.
Absolutely. And I think as communication gets better with the FAA, so if you're flying a commercial mission and that can be communicated through social media or through FAA a website or whatnot, hey, expect to see this, then that's going to help law enforcement. That's going to help people that really are concerned. But you're still going to have the outliers. I mean, we've had the guy, the biker guy in Arizona take shots at our vehicles. We've had that, But then we've also had the people that come out and say, wow, that's really cool. What are you doing? And teach me. So there's always going to be both sides of the spectrum. But I think that communication strategy from the FAA and how law enforcement is able to respond to a phone call saying, yep, that's scheduled, that you should expect that for big organizations that are flying missions, being able to say, hey, we're going to be flying this, it's not an unknown. I think those types of things will help too.
All right. Unless there are any other questions, that'll conclude our program. I'd like to thank both of our panelists today for being here. And thank you, everyone, for coming. Thank you very much.
Thank you.
Thank you.